Oh, hum. Let me put some tunes on. Hum. Hello. Madoka. Koko desu yo. I'm sumimasen. I'm sorry. I had to push it back a little. Technically, the chores were done at around like when I made like the blue sky post around like 6ish, but like when I finished my chores, like I hadn't eaten dinner yet and I hadn't taken a bath yet, and like those are both necessities, so it's just like I need to give myself a little bit more time. So yes, it is a little bit later than scheduled, but initially scheduled, but I am here, and I'm good too, Dawn Seeker, and you are welcome in too. Good to see you guys. But yes, how is everybody? This is Akira Toja, but you can also call me Mar, and today, I've got another test. So we're doing cowork and lurk today. So whether you're watching right now or you're time traveling from the future, you're coming back to the VOD, welcome in as always. I hope you have a good time today. And yes. Yeah. Did I have time to check out the manga? I have not had time to read any new manga within the last couple of days. I've just been like focusing in on my test and my chores. Okay, wait, what have I been doing the last few days? Yesterday morning was studying, and then I didn't do much Saturday morning actually. I did a little bit of studying, and then I ended up napping for a lot of the morning actually, and then like around like noonish I went out and I went to school and I went to study with some people over there, and then I came back home and it was late, and then Sunday I didn't go to the monster truck rally, unfortunately, but Sunday today, I was so productive today. Like, actually, I was so productive today. Do any of you guys ever have a thing where it's like, when you have like something really big coming up, something really big and stressful coming up, you start feeling really motivated to do things, but like, not the thing that you're supposed to be doing? Like, you start feeling like really motivated to do everything but the thing that you're supposed to be doing. That happens to me a lot. So anyway, instead of studying for my test all day, I've literally been doing like everything else. That it's things that I should be doing and things that I did need to do, but also in the grand scheme of things, I probably could have waited until after the test. So anyway, I went to the farmer's market today and I did some grocery shopping. I went to the farmer's market and the grocery store. And then, so I bought like cheese and I bought butter, and I went to at the farmer's market. I bought like sweet onions, 2 of them, and then I bought some cherry tomatoes, and then I think I'm gonna use those to make like corned beef sometime later in the week, and it's gonna be nice. It's gonna be tasty. It's gonna be good. And then I bought a watermelon. It's watermelon season apparently, so I bought a watermelon at the farmer's market. I also bought some peaches. Peaches. I'm disappointed about the peaches, actually. I was expecting some nice, juicy, delicious, sweet peaches. And they are, like, juicy. Like, they're the right color for a ripe peach. They're the right consistency for, like, a ripe peach. Like, you feel them. So they got that kind of, like, ripe peach kind of squish to them. But I, like, cut them up today into, like, little pieces, and I, like, ate a few. And they're tasteless. They're no good. I'm so disappointed. I was so disappointed. And now I have a whole bunch of peaches that, like, they're not sweet. They're just fiber, and I gotta eat them now. Which is okay. They fill my belly. It's okay. I don't know. Last time I bought peaches, I didn't go to the farmer's market. I actually went to, like, a different, like, produce stand, like, further out. It takes a little bit longer to get there than it takes to get to the farmer's market. The farmer's market is closer to my apartment, but like, anytime I want fruit now, I think I'll just like take the extra time to drive out to that fruit stand on that farm that I went to the other time, because those were good peaches. Those were really good peaches. They weren't even ripe when I bought them that time, but they were so sweet. What? I don't know. Isn't it like getting towards like the tail end of like peach season too? Aren't we going into like apple season more now? Maybe I bought the wrong thing. Maybe I should have bought apples instead. Maybe I'd be a happier bunny if I bought apples instead. I don't know. After I finish all of my fruits, maybe I'll go out and I'll buy some apples. Cause apple season lasts until like October, doesn't it? I got time. Anyway, yes. Depends on how big it is. Oh, you do other things. Very big, no anxiety. Oh, yeah. It's just, I want to feel like I'm doing something, but like also, it's just like, this is big. I don't want to touch this yet. I just do other things. You guys had a turbocharged day stocking joins with the output stocking rate skyrocketed for some reason, just emptying one box after another. I don't know. To be honest, like, I'll preface this by saying I want to be in school right now. I have been like working towards getting into this program and like trying to get like the career that I'll get after I get my degree for a very long time. So I want to be in school right now. I want to be in this program, but I will preface what I'm about to say with that. But like, if you were to ask me if I prefer school or work, I think I prefer work, because like, you go to work and then you come home and then your time is just your own. You don't have to do anything else after you come home from work. Like, work gets done at work, and then theoretically, if you're like, you know, on the clock, off the clock, you come home. There's no more work to do. It's just your time. School, you come home from school, there's so much studying to be done. There's always studying to be done. School follows you home from school. And I don't know. I just kind of miss like being able to come home and then like my time is my own. Eventually, though, it'll happen. It'll come back. I just gotta wait like 4 years, 4 or 5 years. But yeah, I don't know. It'll be back eventually. It's just a little, just stating my preferences over here. Yeah. Yeah, it's like it's better if I finish all the other things so this test project can take all the time it needs. Right? You think of it like that, because like if you don't get the other things done, then they just kind of like weigh down on you. It's just like, I gotta get all of this stuff done. You're just sitting there like thinking about it, and you can't focus on like prepping for the test or whatever other big thing that you need to be doing. So I got all my chores done. I did a whole bunch of laundry today too. I washed all my clothes, I washed the towels, I washed my bedding, my sheets and stuff. Now everything's all clean. I forgot to wash my desk mat. I don't wash that in the washer though. I wash that like, I take it over to the tub and I like scrub it down by hand, and then I like put it on my little drying rack and I let it dry like that. Yeah. I spilled some like soup on it the other day, so I need to wash it. That's okay. It will be washed eventually. What else I did a lot of cleaning today too. I cleaned all my countertops, and I like took my vacuum and I vacuumed up. I was super brave, and I like went over to my windows and I vacuumed up all the spider webs and all the little itsy bitsy spiders that have been like crawling all over my windowsill. They're all in the vacuum now. So yes, everything has been vacuumed. I cleaned the toilet. I cleaned the sinks. I think I already said that though. I wiped down I mopped my floors too. I literally did everything except studying for my test today. Everything except the test today. So yes, now I'm sitting down to do that. So I think this is a good way. I think that's a good segue into, let me tell you about how I'm planning on studying for this test today. Yeah. You see, I'm not going to spend the entire stream just yapping to you guys while Animal Crossing music plays in the background. Do you like it, by the way? It's a little something different. I think it's just like a mix of like music from a whole bunch of different Animal Crossing games. It's not like one specific game. It's like a 3-hour playlist. So if I end up studying past like to the end of this playlist, I think I'll go find a different one too. But like, nice and soothing. Yeah. I wanted something nice and soothing for something new, but also nice and soothing. I think like the funky game jams that we had going at the end of last cowork and lurk stream might have been a little bit too intense. So we're going with something tried and true this time. We're going with Animal Crossing. But yes. So my test tomorrow is about metabolic pathways. So I need to know about vitamins. I need to know about how we digest sugars, proteins, fats, nucleotides, and then yeah, amino acids as well, but that goes with proteins. Proteins are made from amino acids. So yes, I think I'm going to start out by just like drawing and writing out all of the different like pathways that I need to memorize for the exam, and then I'll sort of just like mumble to myself like a crazy person. If you want to follow along, go ahead. It'll be just like last cowork and lurk stream pretty much. I'll just be here talking to myself. I'll be talking to myself, I'll be watching what you guys are saying in chat, and like I'll be trying to answer questions and trying to focus and trying to do stuff. But oh, comments are closed on the... I did not know that they were closed. Oh wait, let me check up on that real quick actually. Thanks for letting me know. I didn't know that the comments were not open. Wait, how many streams has that been? Static Dread? Is the comments open on that one too? Let me check like the last couple of streams. I didn't know that the comments were not open. That one looks okay. Wait. Baba is you. Or Right. Wait, give me a moment here. Let me grab my cell phone and I'm gonna see if I can see the comments if I open the stream up from there. Obsidian, welcome in too. Dealing with the effects of edible regret. I am so sorry. Just sort of let the Animal Crossing music sink in and try not to focus on the regret. Yeah, okay, wait, there it is. YouTube app. And then I go here, and then I go switch account, and then I go over here, and then I go over here, and then I open this, and I go here. Oh wait. What do you mean comments are turned off? What? What do you mean they're turned off? Okay, wait, let me see if I can turn them back on. Oh. On. Yeah. Okay. The comments should be back on for last stream now. Sorry again, I don't know why they were turned off. Wait, the Static Dread comments are turned off. Why? How many streams have... Okay, no, last cowork and lurk was comments were turned on. Truly odd. I don't know how that happened. Wait, comments on for this stream? Yes? I like reuse like the same settings for like almost every stream, and I just like change the title and the thumbnail. So I have no idea how those two streams got messed up, but comments are back on now. Sorry again, guys. I didn't know. I don't know how it happened. Truly strange. Yeah. Because YouTube has been very wonky recently. I don't know. You want to know what's been happening to me sometimes when I try and watch YouTube videos? Beyond like the auto dubbing and like how I can't turn that off apparently if I open up like YouTube on my phone's web browser. Sometimes I'll open up a YouTube video and like none of the thumbnails and the recommendations will load. It'll just be like a big long line of like no thumbnails. I won't be able to see like any of like the titles or titles of the video stuff either. It's just like a big long list of like channel names, and it's weird. I have to like reload the page a couple of times and then they come back. I don't know what's up with that. It hasn't happened today though, which I guess is good. YouTube is always wonky, I feel like. YouTube's always doing something. Maybe I should start pestering Twitch again about getting that old channel of mine back. Which I can't believe they ghosted me. YouTube has been auto-activating restricted mode on some people. Is that what's happening to me? That was happening to me? There's like nothing like restrictable in those streams though, I don't think. I don't know. Maybe I just got unlucky on the bug RNG. I don't know. Hopefully this stream stays okay. Yeah. Okay. Well, that has been fixed. Okay. Anyway, back to talking about what is on my test. As a veteran YouTube user, you can say I can tell a veteran from a new... Oh, yeah, you can tell a veteran from a newbie simply by how they treat new YouTube changes. I don't know, I feel like it's always a toss-up. Like, are they gonna change it back, or are they just gonna leave it? And, like, everybody's just gonna sort of go on with life, lamenting the days when things were better. I feel like it's a 50-50 chance. It could go either way. I really want the auto-dubbing to go away. Or at the very least, I want the option to turn it off. I open videos on my phone's web browser. Oh. But yes, anyway. For today, I'm going to write out all of the pathways that I need to do. There's like some like disorders and diseases and other unhealthy states of being that I need to be familiar with for the test as well. So I think I'll make a list of those and then I'll kind of like work through like where all of those are on each of the pathways. And then I will, what else will I do? I'm gonna divide this into like 3 real quick, okay? And oh, there is a study guide that one of my professors gave out for the vitamins section of the content. And I don't think that I should show it on stream, but like I can like work on it off stream and just sort of like read out the questions and stuff. So I think that'll just be good. It'll be like Mar tells you about vitamins ASMR. Mar tells you about vitamin B. What was it like? B2? B2 deficiency? One of the vitamin B deficiencies is called like berry. I need to know it for the test. Wait, which one was it again? It's a B2? Thiamine. Thiamine is vitamin B1. Oh, okay. Berry is vitamin B1 deficiency. Remember that. There's another one. I remember what it was called. I don't remember which vitamin it was. It's Pellagra. Pellagra is vitamin... It's another B vitamin deficiency. What is it? Niacin? No, it is niacin. Niacin is vitamin B3. Anyway, vitamin B3 deficiency is called Pellagra. Pellagra? Oh, not Pellagra. Pellagra. Excuse me. So, yes. Oh, should I explain from the beginning again? Okay. So, I have a test tomorrow. It is about metabolism. Wait, I don't think my grade is showing up correctly again. Hold on. Like that. Please work. Is it? Okay, there we go. Hey, there we go. Okay. My screen is working. I have a plan. Okay, let's start from the beginning again. So, I have a test on Monday, which is tomorrow. It is on metabolism and the vitamins. So, I am going to sit here. I am going to draw all of the metabolism pathways that I need to know for my test. So, I need to know about sugar metabolism. I need to know about lipids, so fats metabolism. I need to know about cute, welcome in too, by the way, I just noticed you in chat. I need to know about nucleotide metabolism. I need to know about protein and amino acid metabolism, and yes. So it is going to be a very small metabolism. We're not like overall like eating and mastication and then go through the stomach, come out the other end, digestion, general like physical processes, large physical processes, metabolism. It's more like smaller, like on the molecular level metabolism that my test will be on. So yes, I'm going to draw out a whole bunch of chemical pathways and I'm going to do my best to talk them all out and hopefully they'll stick in my brain and I'll get a passing grade on tomorrow's test. Yeah. Okay. So yeah, just like the last cowork and lurk screen. Dream. Feel free to listen in, follow along, ask me questions, maybe we'll work on something else off to the side. Put the lurk and cowork and lurk. No, do a little bit of this, a little bit of that. Whatever you need to do. So I'm gonna make this a little bit bigger. I'm gonna do 40 point, okay. I'm gonna, okay, wait. So if I do fats, let me, I'm gonna, gonna put that in half. And then, yeah, okay. And I'll leave that for now. Okay, I'm gonna put sugars in the middle. Yeah, right there. Okay, and I have my school laptop up to the side here. I have a whole bunch of PowerPoints open. I should actually go grab my phone because when I was like studying with friends on Saturday, drew out a whole big diagram on the whiteboards at school, and I think it'll be easier if I don't like flip through my professor's PowerPoints and I instead just look at the big diagram that was made last Saturday and copy that down again. But let me open things up. I don't think I wrote down the enzymes I need to know on my section of the PowerPoint though. Wait. Camera. Yeah. Okay. Okay, so I'll start with sugar metabolism. Okay. Okay. So you have sugar in your body. We will say there are a couple different kinds of sugars, but we will focus in on glucose. I'm gonna put it down here. Glucose. We'll say, hey, that's sugar. And then glucose goes to, you put a phosphate group on the glucose to make it higher energy. When you put phosphates on stuff, it makes it higher energy, and so then it becomes glucose 6-phosphate, because like there's 6 carbons in glucose, and so you name it based on like which carbon that the phosphate is attached to. It's like shaped like, you know, like that. And then the phosphate will be somewhere on there. Like a little bug, it looks like. Glucose is like, it's like generally you take different sugars and they're either broken down into glucose or they will be broken down into something that goes further down the glucose chain. So like, let me like finish drawing a couple more diagrams here. So like there's glucose, and then glucose turns into higher energy glucose with the phosphate group on it here, and then glucose then gets turned into a different sugar called fructose. Maybe I should use a different pen. I feel like this is not a good pen for writing. 10, 18, 19, 20. Let's go 28. Cool. So fructose. That's too big. 6-phosphate? Yeah, 6-phosphate. I'm just gonna finish drawing out this path to a certain molecule, and then I'll go back and explain things. Fructose, then you make it even higher energy, you add on another phosphate group, and it becomes fructose 2,6-biphosphate, oh, bisphosphate actually. And then there's some steps in the middle here. It's a process called glycolysis. I don't need to know like the separate steps for my test, so like I'm gonna save a little bit of time and I'm not gonna write them all out, but eventually you end up with a different sugar molecule called phosphoenol pyruvate. Go down a little bit further. You take the phosphoenol off and then it becomes pyruvate. I think metabolism processes is definitely where you start to see some of the just throw things until it works in the human body. There are many, it's very convoluted, there are many steps everywhere. Anyway, Pyruvate is able to go into the mitochondria, the powerhouse of the cell. So it goes into the mitochondria, and then in the mitochondria it'll become a molecule called acetyl-CoA. And acetyl-CoA is very important. Acetyl-CoA is used in many things in many places. But let me go back. So glucose, I believe starch can be broken down to glucose. This was something I should know from last test. Hold on. I really should actually review this. So let me open up a few things and then we can go through it together. I could use a review too, honestly. Where was the sugars again? Where is it? There it is. Okay, I'm gonna open this up real quick. Okay. Okay, yeah. Yeah, so there's a couple different types of sugars in our diets. So glucose is, there's like big sugars and there's small sugars. And when you have, so the sugars that you eat through your foods are like the polysaccharides. It's like the big sugars. But you want to break them down into smaller sugars because that's what your cells can use to make energy. And so like when you eat like potato or like something, when you eat like potato chip or something like that, like potatoes, flour, things like that, you're eating like starch, and starch can be directly broken down into glucose, and then that'll go through like all the metabolic pathways and eventually you end up with energy. But like there's also other sugars that you can eat that are like can be broken down to simple sugars that are not glucose. So say that you eat like, say that you're eating like cookie, or like you're drinking fruit juice and it's got like, not cookie would also be glucose I think, but like say that you're actually, what's table sugar is sucrose. What does it break down into though? Sucrose breaks down into glucose and fructose. Okay, no, so yeah, say you are eating cookie or you're drinking fruit juice or something like that. You break it down into a different simple sugar called fructose. So that's 1, 2. 2, 2 is a different molecule. These are something else. This is wrong. Okay. Yeah. So you can also eat, I'll put it over here, fructose. I'm gonna make this smaller real quick. Did I put this on the same? I did put this on the same layer. Okay, wait. I'm gonna take this. I'm gonna take this. And I'll put this on its own layer, and then that's good. That's good. That's better. Then let me make it a little bit smaller. Put that over there. Okay. Okay, and then I'm gonna put fructose over here. Ooh. 15. Fructose. So you eat fruit juice. You eat the fruit juice. You're not drinking it, you eat the fruit juice. Because I said you eat the fruit juice. So fruit juice. There's like the fructose also needs to become higher energy, so you will also add phosphates onto the fructose after you eat it. So that becomes fructose 1 phosphate. And then it becomes glyceraldehyde. Do I need to know all these molecules? I probably do. And then you add mother phosphate onto the glyceraldehyde. Glyceraldehyde 3-phosphate, and then that also goes back into glycolysis, and it goes back into the energy making cycle over there. What other ones do I need to know? Galactose is another sugar that can be eaten. Oh, it comes from lactose, so galactose you would get from eating milk. So that joins in somewhere else. So when you need to store sugars as sugars, you can also store them as fat, but when you're storing as sugars, not over there, over here. You would take the glucose 6-phosphate and you change the position of the phosphate, so this becomes glucose 1-phosphate. The glucose 1-phosphate can be... You can stick them together like Legos and they turn into this molecule called glycogen, which is basically just like you take a bunch of glucoses and they kind of like branch off on each other like that. I think it's like every 4 or something like that. There's like another branch. Anyway, you make like glycogen is basically just like these big like glucose like snowflakes. So that's how you store like sugars as sugars again. You store them like as other ways too. Fructose like corn syrup, yeah, I like corn syrup. Why do scientists give long names to do things? It's supposed to describe the structure. So like you have the base thing. And then like phosphoenolpyruvate. Pyruvate is its one. I don't know the structure for pyruvate, so we'll just say that pyruvate's like this. I don't need to know the structure for the test, so I don't really want to look it up either, but like, we'll just say that pyruvate's like this, and then phosphoenol, the phospho is like, there's a phosphate group on it, enol is like, I believe it's like an alcohol group, which is like an oxygen and a hydrogen together, so you just describe things. You either, yeah. Co-A is like coenzyme A, that's its own molecule. The acetyl group is... The acetyl group also like describes the structure or something. It's like, yeah. Acetyl. I'll make sure I'm thinking of the right thing. Yeah. Okay, yeah. Acetyl is like, it's like you have your thing here, and then the acetyl group is like there's a carbon. Bring it back. Okay, there's a carbon down here. And then there's another carbon here, and then there's like hydrogens attached to the carbons. Then there's another oxygen up here. It's just like names to describe like structures, and then like that's how you end up with like super duper long complicated sounding scientific names. It's because it's just like a really big molecule, so they're just like sticking like Legos sticking together like the names of the different components of the molecule. Because if you've been studying this for like 20 years of your life, I suppose you would like memorize, it would be enough time to memorize what everything is and how everything fits together. Yeah. Okay, so what was I doing? So yes, glycogen. So glycogen is the snowflakes of glucose put together that you store in your body, in your liver in fact. They're there. The glucose 1-phosphate, you can get that from galactose 1-phosphate, which comes from galactose, which again you get by digesting lactose. So, yeah, basically, you eat a sugar, it will turn into pretty much one of these three, and then it'll just like go into the metabolic pathway, and you'll digest it. And you'll either get energy out of it, or your body will say, no, you don't need it anymore right now, and it'll turn into like glycogen stores or like fat stores or whatever you need. So acetyl-CoA is a really cool guy. He's a real popular guy. Everybody loves acetyl-CoA, so he's going everywhere. He does everything. High school chemistry. Oh, I like it when chemistry isn't math. I remember when I took like a chemistry class in like undergrad, like there was like a portion of the unit where like they had like everybody memorize a whole bunch of like diagrams, and like you had to like memorize like the chemical structures of like different molecules and stuff, and you had to like draw like arrows out for like where things react, which like components of the molecule react with like which components of like other molecules and like stuff like that. And I remember, and like you had to make like arrows and stuff like to show like where the electrons were moving and like what bonds were changing and where they'd move, and like I liked that one. That was fun. It felt like puzzles. I completely forgotten right now too. Yeah. I swear one day we're gonna actually accidentally create a magic spell from all the Latin we use in chemistry. Sometimes I feel like saying all of these names, it feels like I'm speaking in tongues. Okay, anyway. That's right. Acetyl-CoAs. So continuing with sugar metabolism, our friend acetyl-CoA. Let's start back up with him over here. Acetyl-CoA. So we take the acetyl-CoA. Now where does it go? It goes... We turn acetyl-CoA into... I actually need to memorize this pathway, so I should probably try and test myself and see how many of these I remember. It gets turned into a molecule called citrate. And so there's a big cycle here. Citrate... Maybe I should put this on its own layer. Okay. Yeah, citrate. You change the structure slightly and it gets turned into isocitrate. The iso just tells you that it's citrate, except like slightly to the left, a little bit different. I think it did turn to isocitrate. Wait. Yeah, isocitrate, and then isocitrate gets turned into a molecule called alpha ketoglutarate. And actually, I shouldn't be writing this here. This can't go backwards. This only goes forward. Alpha ketoglutarate gets turned into succinyl-CoA. This gets turned into succinate. Fumarate. Malate. I believe malate gets turned to oxaloacetate. Yeah, and then oxaloacetate can go back to citrate. So this can't go backwards. I think that all these can go backwards. This can go backwards. This can go backwards. Yes. Oh wait, I should be writing down enzymes. So, Enzymes are the proteins that actually like turn one molecule into the next molecule. So glucose, it's either... It's still too big. Okay, wait. So this reaction will be done by hexokinase if you're outside the liver. Or if you're inside the liver, it'll be done by glucokinase. Pancreas too. Okay. Then so let me move that over here so that I have more space here. This is like phosphofructokinase. I'm just gonna write PFK. There's two PFKs. This is PFK1. There is a different reaction that goes down here when you eat a lot and you don't need any more energy. This can get turned into... You change it just so ever so slightly. It becomes fructose. 2,6. This is the 2,6. Bisphosphate. So this is PFK2. This is like right here. It's like glucose dehydrogenase? No. Phosphoglucomutase. Protein kinase F. What? Glycogen synthase. Let me look at my professor's slides really quickly. Where is carbohydrate? Glucose, phosphogluco. No, yeah, PFK. Deoxyacetone, pyruvate. Oh, I need a pyruvate. Let me actually go here, type in. The right lecture? No, this is not the right lecture. Okay, wait. Glycogen. This. Tell me how it's made. Yeah, glycogen is. Glycogen, glucose 6-phosphate glucose. Yeah. Wait. Okay, no, I see. Oh, okay, wait. Yeah. Really do gluconeoge. Oh, I should note of that actually. Okay, wait. So let me go over here. Let me get rid of this. Then I'm gonna write stuff in a different color so that things make more sense. To me, at least. So I'm gonna put that there. And then... So... When you go... glycogen to glucose 6-phosphate. That would be glycogenolysis. Yeah, maybe I should. I'm gonna get too busy if I do this. Let's not. I'll just do it anyway. Well, I might get too busy. Okay, that's okay. I'll just... Okay, glycogenolysis. Sugar... Say sugar paths there. Okay, cool. So glycogenolysis. I'll make the next one horrible. Glucose 6-phosphate to pyruvate is the glycolysis path. Okay, so I'll go like here, here. Maybe I should go over here actually. Here, here, here to pyruvate. That is glycolysis. The building up pathways, pyruvate to glucose. I'll make that green. Pyruvate. Oh wait, I did not want to do that. Pyruvate will go up to glucose. Call that gluconeogenesis. And then Hornash. Do glucose to glycogen, glycogenesis. Okay, so glucose to glycogen, glycogenesis. Okay, so there's those. This is... I didn't label this. This is called TCA cycle. Okay. That's that. I didn't know about this. Okay, yeah. I don't need to know where they come from, but out of the TCA cycle you get... high energy molecules. They're called... you get FADH and NADH. Okay, and then those go into neutron transport chain, and you get... what do you get? You get energy out of that. Yeah, okay. So... that is path number... we'll call that path number 1 right there. Need to... maybe let me go over here and... I might... I'm gonna get rid of this actually, and then I'll just redraw lines as I need them. So... Let me put like fat metabolism. Fat metabolism on here next. So I'm over here. So acetyl-CoA. We're going back to acetyl-CoA then. Acetyl-CoA gets turned into, what is it, propionyl? Malonyl. Gets turned into malonyl-CoA, and then I think it becomes, nope, it becomes fulminate. Why am I drawing this over here? Put there. Okay, and then take that out of there. Group. N. Palmitate. And then palmitate can be turned into fatty acid. I believe? Yeah. So if you add a coenzyme A onto the fatty acid, it becomes higher energy. You're not adding phosphates onto the fatty acids to make them higher energy. You instead add coenzyme A's, so that becomes a fatty, call that acyl-CoA. And so fatty acids are like usually like really long things. They'll have like essentially what they are is like just like a bunch of like CoAs strung together basically, and you want to like chop them off. You want to chop them off so that you can use them in other places. So you chop them off 2 at a time. So if you have an even number of carbon molecules inside of your fatty acid, you just end up with a bunch of acetyl-CoAs. So if you have an odd number of carbons, you stop at 3 carbons, and so that one is called, I think it's palmitate? No, propionyl-CoA. This is why I'm studying. Where's palmitate come in? Why do I keep thinking? No, palmitate was earlier. Okay, that's why I was thinking palmitate. Palmitate is up here. I literally just wrote it. Okay. So this gets to, you stop at 3 carbons, which is propionyl-CoA. And then you turn it into succinyl-CoA. Which we have seen before. It's over here. And so this can end up, that can loop back around and go into the TCA cycle. So those connect. Everything's connected. Everything's connected. I don't like that big line there, so I'll just write 2 TCA. I'm gonna make this smaller. Okay, so I'll put that. I'll put this over here. I think there's something else I need to use this for. Chimjica. Oh wait, what is this? Oh, while we're talking about here, this is sugar pats. Over here will be our fat pats. So those are fatty acids. You can also like just eat fatty acids straight up. Like, you know, when you eat fish or you take like omega-3 fatty acid supplements. Yeah. So acetyl-CoA can also, let me make a line here. Acetyl-CoA can also go to, we'll restart. You can turn it into something called acetyl, oh man. Acetyl-CoA. This gets turned into a molecule with a big long name. I'm just gonna abbreviate it. HMG-CoA. And then HMG-CoA. There are two pathways that the HMG-CoA can go down. Take these. Oof, okay. HMG-CoA, you can turn it into acetoacetate, or which can be turned back and forth to a different molecule called 3-hydroxybutyrate. Metabolism really is complicated. Yeah. Oh, I wish it was simpler. You never really registered our bodies really are just walking and talking chemistry facilities. Everything is chemistry. It is inescapable. It is everywhere and always going on. It's fascinating though, like how many, like if you consider like you and like how you get energy and how like bugs get energy, it's not so different. It's the same pathway, really. Like if you get small enough, everything ends up being like quite similar. So 3-hydroxybutyrate. Acetoacetate can also just randomly turn into acetone inside of your body. You don't want that to happen, but it does happen. So we're gonna come back to this because there's actually I mentioned earlier I was gonna talk about like disease states and like disorders and stuff at different points in the pathways because I need to know them for my exam. We're gonna come back to that. So when we're not turning HMG-CoA into acetone, it instead gets turned into cholesterol. So if we go down the cholesterol path, melanavate, melavonate. So that gets turned into a molecule called melavonate, which gets turned into a molecule called isoprenoid. It's turned into a molecule called squalene. Squalene? I think it's squalene. Squalene, and squalene gets turned into lanosterol. Lanosterol, you will turn that into cholesterol. I need to know, let's see. There was cholesterol synthesis. Cholesterol-rich lipoproteins. That's not what I want. Cholesterol. Yes. Cholesterol ester. Choline, cholesterol. Yes. What specifically does cholesterol turn into? Cholesterol. Oh wait. Different cholesterol. I guess it's not like a specific. There are different types of cholesterol, so I guess like it doesn't make like one specific cholesterol in that path. Just generally, if you need a cholesterol, or if you don't need a cholesterol, you get it from here. Cholesterol. Okay. Cool. So we'll just leave that at that. Okay, I did that. Okay, I'll go over here and we'll say what is this? Too much for me, that's what it is. Oh, great. Goodness, it's so much. Maybe I'll just put that in the... Okay, no, I should write this. Okay, I'm gonna write something over here real quick and then we'll just come back to it. I'll see if I can, like, explain everything, how it's all interconnected at the end. So, there's a sugar that your body makes. It's a derivative of like a sugar called ribose. Your body needs it for like nucleotides and stuff. There's other stuff that comes out of this pathway too, though, so it's like the pentose phosphate pathway. For short, the PPP. So for the PPP, we take glucose 6-phosphate. You remember that guy. You remember that guy. Maybe I should write down. There's also somewhere in here where like you can directly make lactose. I have to look back up where that is too and put that in there. But we'll come back to it later. So glucose 6-phosphate, instead of being turned into fructose 6-phosphate, you will instead turn it into 6. That's a G. 6 glucono delta lactone. Yeah. And so 6-phosphogluconolactone. There's a whole complicated thing with it, but essentially you make ribose 5-phosphate, and you're also making NADPH, which you need somewhere else. Oh wait. And so you can do one of two things with this. You can make nucleotides if you have a need for making more DNA and DNA derivatives, or you can make more fructose 6-phosphate. There are lots of stopgaps in metabolism where, like, if you have too much of one thing, you can just, like, shunt off one path and, like, start making more of a different thing instead. Lots of checkpoints everywhere. So yes, that's important there. There's another disease that has to go on with, like, dysfunction over here. Oh, alcohol. When you drink alcohol, it also makes, like, so the main alcohol in drinking alcohol is ethanol. So when you drink alcohol, you'll, like, digest it into, like, did I write down the specific path for that? I don't think I did. I don't remember what this turns into. I remember, like, the enzymes, though. It's like, I should, like, make this smaller. Yeah, so that's alcohol. Alcohol dehydrogenase. Aldehyde. Dehydrogenase. I was learning about these two in, like, a different class. Not for the test that I'm taking tomorrow, but, like, a different class. I learned more about this too the other day. Shoo, welcome in. I am studying for my metabolism test tomorrow. So anyway, whenever I'm just, like, drawing out metabolic pathways and I'm trying my darndest to explain what's going on here. So, like, when you drink alcohol and you digest alcohol, you make a lot of NADPH, and you kind of, like, trick your body into thinking that you've been fed, even though, like, no nutrients are really going in. Which isn't good, because, like, you get malnourished, but at the same time your body is still, like, thinking that it needs to, like, start storing fats and, like, start storing sugars and stuff like that. So it's just, like, it's not good all around. Don't drink alcohol, it's not good for you. So that's what happens when you drink alcohol. Dose phosphate pathway. I need to write about I think actually I'm gonna take this and I'll put it down over here. If I do cowork and lurk, assume that I have an exam coming up. Yes, another test. My constant state of being. Okay, this goes up here. Yeah, that goes up there. So move that down there. Why did I do that? Okay, no. Let's go with protein. Oh, protein. Okay, no. Most important thing in protein digestion would be the urea cycle, which is glutamate. Oh, glutamate. Wait, where does glutamate come from again? Glutamate is an amino acid, but you can also, I'm pretty sure you can also make it somewhere through some pathway. Oh yeah, it's... Okay, let me draw this out. Okay. Go... protein, specifically at a larger scale. Nitrogen paths. So it's good. I can handle it. It's good. It'll be easier if I do it like this. Okay. So... No, I don't think it'll be easier if I do it like that. It'll be easier if I do it like this. Okay. I'll go over here. So you have... There's carbon dioxide in the body at all times. You're making it all the time. And then when you eat protein, you end up with nitrogen. Usually in the form of amines. So you have your nitrogen, those come together to make carbamoyl phosphate. I'm a little disappointed because like last exam my professors gave out like a whole bunch of like study guide. The professors for this class at least gave out like a whole bunch of study guides. Study guide worksheets, and I did them all and they were really good studying. And I ended up doing like pretty okay on that test. I didn't do bad on that test at all. This turns into citrulline. But there's just like, there's a single study guide for this test, and like everything else I'm just on my own, studying everything on my own. Which is okay, but also, it adds to my stress. Okay, so citrulline turns into arginosuccinate. Oh. Succinate. There we go. Mama, welcome in. No school because rain. Must have been a lot of rain. Stay safe out there, okay? I am studying for a test that I have tomorrow. I'm sitting around, I'm mumbling to myself like a crazy person about metabolism this time. This turns into arginine, which is an amino acid. Not too big. Make it smaller. Oh, actually, I could. No! I can just go up here, and I can do. That's ornithine. Okay, and ornithine can go back to citrulline. And this right here is called urea cycle. Because we make urea. I haven't shown you guys where we make urea, but it comes out of here somewhere. It comes out right here. Ew. Pee it out. Okay, and then arginosuccinate. Let me move this over because that one's important. It does other stuff. So I'll put this over here. And so arginosuccinate. I'm gonna put this somewhere else actually. Urea cycle. Arginosuccinate can get turned into. Well, you make arginine, but it turns into two things. It turns into arginine and also turns into. You like chop it in half, and then one half is arginine, the other half is fumarate. No, this. I think this is important, like some kind of vitamin deficiency. That's why I keep looking at it and thinking about like there's something important about this. I think it has to do with some kind of vitamin deficiency. I gotta go back and check though. Anyway. Oh, remember from our TCA cycle over here. Fumarate can turn to malate. Malate turns into oxaloacetate. Okay. There's something else important about this. Oh, Propionyl-CoA. Where was that again? This guy right here is important for later. But let me finish up what I was doing over here real quick. Aspartate, fumarate, no succinate, yeah. Oxaloacetate can also turn into okay, there's a whole. So amino acids are just sort of like there's no one single pathway. They're just sort of like sprinkled around everywhere. That's what I'm like. I'm like looking at all the diagrams that I have in my notes right now, and I'm trying to figure out what's going on with all of them. And I see now the amino acids are just sprinkled around everywhere. So you get nitrogen off of proteins, but you also get like a whole bunch of amino acids, and so Amino acids. Amino acids. Maybe I should use a different color for them. I used every single color here, though. Here, I'll use, like, this kind of color for amino acids. So... here, do that, and then... TCA, basically. Okay. TCA. Actually, no, I should write that out because this has to do with a vitamin deficiency. Okay, wait. Oh. This won't just go into TCA. There's actually something to do with this. So... a lot of these reactions are being like passed back and forth between the mitochondria, powerhouse of the cell, and the outside of the mitochondria. So there has to be a way to like move things like in between like the cytosol, just like the liquid portion, the general liquid portion of the inside of the cell, and then the inside of the mitochondria. So oxaloacetate, we can turn it into an amino acid called aspartate. Then aspartate aspartate's able to go like in and out of the mitochondria basically. So we'll call this... well, urea cycle happens inside of the... so right now we're in the mito, but we need to go out mito. And sometimes we need to go back in mito. So in mito, aspartate goes into the mito. After it goes in, it turns back into oxaloacetate. Can I like shorten this anyway? I'm just gonna say oxalo, and then I'll know what I mean. So anyway, oxaloacetate goes back in. I should put this a little bit off to the side because there's something else happening here. Oxaloacetate gets turned into malate. So malate can go back into the mito and turn back into oxaloacetate. And so that's how you're able to move oxaloacetate in and out of the mitochondria. Powerhouse of the cell. Yeah, malate. So acetate. Important. TCA cycle happens inside of the mitochondria. Remember right here, this is where we delineate into the mito. Circus in your stomach is dying down. That's good. That's good. Okay. And so there's a different reaction that's like coupled with this because like they happen with like the same enzyme. So you have glutamate, which is an amino acid. Can go in and out, or it can go out of the mito. That's the wrong way. It's because I have it on the opposite sides in my diagram here. That's why I'm looking at it the wrong way. Yeah, aspartate goes out of the mito and turns into oxaloacetate. That's right. Aspartate to oxaloacetate. Okay, no, you start with alpha keto G. Gets turned into glutamate. Wait. No, wait, no. No, no. Okay, wait, no. Oxaloacetate 2. That's the wrong one. Malate 2. These are on the wrong sides, that's why I'm getting confused. Okay, no. So outside of the mitochondria. Aspartate will get turned into oxaloacetate, which will turn to malate, which goes into the... malate, which goes... No. No, I did have that right. Wait. Gosh, wait. Wait. Okay, no, malate... starts out of the mito, it goes into the mito. Yes, that's right. Yeah. Yeah, and so when we have aspartate, it gets turned into oxaloacetate outside the mitochondria. That's right, too. Okay, no, that's right. No, yeah, okay, so this goes over here. Glutamate will go into the mitochondria. Then... there's an enzyme called PLP at both spots over here. So using PLP, oxaloacetate goes to acetate, but also glutamate goes to alpha-ketoglutarate. Ketoglut. And then that's able to go outside of the mito. Ketoglut. Okay, and it uses PLP again on the outside, and it turns back into glutamate. And those things just move around like that. That's called the malate aspartate shuttle. I guess we also get NADH out of this. Outside of the mito, though. When oxaloacetate gets turned into malate. Oh, wait. Aspartate. Oh. PLP isn't used over there. PLP is used over here. Okay. That goes there. And... yeah. So out of this we get NADH. Which is important over here. And for here. I guess that's it for that. What else am I doing over here? Citrate, isocitrate, alpha keto. Oh, that's right, alpha ketoglutarate is this. So I'm just gonna take this and I'm gonna write in where all the amino acids go. Okay. So you can have glutamate. It will turn to alpha ketoglutarate via PLP as we covered up there. You can also make amino acids. Okay, wait. Oh wait, liver enzymes. Liver enzymes, I should know those too. Okay. Alanine aminotransferase. I'll just write like liver enzymes. Important here. And we'll come back to it. Okay, we'll come back to it. I need to know about how fats are stored. Made triglycerides. Okay, wait. Should go over that real quick too. Oh, science, you're not kind to me at all. Oh. Okay, wait. Glycerol. Enzyme, no idea. Wait, can this go backwards? I think... No, it's different enzymes. Okay, wait. Here, why don't I just draw like off to the side instead? There's a different path through which citrate can once again become oxaloacetate. So... oxaloacetate can turn to malate, but when we do this, we also end up we can go back to acetyl-CoA. We make acetyl-CoA out of other things. Hmm. Yeah, when you turn malate to oxaloacetate, you get out NADPH. This is malic enzyme doing that. Okay. And the NADPH, you use this when you store fats as triglycerides. How do you do that? What do I need to know about this? Okay. Yeah. So, other steps here. So when we are doing our other steps, I'll go ahead and put this over here. So we have glucose. We take glucose down through all of this, we go to our other steps, and we end up with a molecule called DHAP. DHAP becomes glycerol 3-phosphate. Yeah. Okay, yeah, so eventually glycerol 3-phosphate becomes triglycerol, and so either it gets stored in the body as fat, or it'll go into the bloodstream. And that becomes blood cholesterol. Wait. Okay, so that becomes Okay, wait, so jeez. LDL, it gets turned into IDL. How do you make... I guess it's just completely different. Yeah, I guess that's just completely different. Alright, well essentially this turns into LDL. Usually when you talk about blood cholesterol, like bad cholesterol, you're talking about LDL over here. And then HDL, good cholesterol. Even though technically they're all separate from these. So... LDL... Okay, yeah. Triglycerol. I keep saying that, but then I don't actually explain anything. Hold on, let me gather my thoughts here. Okay, so triglycerols are the fats that your body holds onto and stores. You'll either store it just as like, you know, fat, or you'll package it up with cholesterols and it'll become VLDL, very low density lipoproteins, which can be converted to IDL, intermediate. Like, is it intermediate? Does it stand for? Yeah, intermediate density lipoprotein, which will turn into LDL, low density lipoprotein. Which, you do use it for stuff, it does get broken down, but generally a lot more of it hangs around in your bloodstream and just kind of like sticks to the walls of your veins. It makes plaques and increases your risk of getting a heart attack. As opposed to HDL, which is completely different. That's also a lipoprotein. HDL will go to the liver to be broken down so it doesn't stick around in your body. Which is why it's generally called good cholesterol, because that's the one that gets cleared out while the LDL is the one that sticks around. Cool. Okay. else do I need? I still have not done anything about the amino acids. Alright. Tyrosine, what do you do with those? Oh. Ooh. Let's save that for a little bit. I'm gonna do... Well, actually, I should. Okay, we'll write down these next. Okay. Amino acids. Amino acids. Breaking down amino acids. You've just eaten a very protein-rich meal, many amino acids. So... phenylalanine is an amino acid. Phenylalanine can turn into a different amino acid called tyrosine. Tyrosine will turn into a molecule with a very long name. Hydroxyphenylpyruvate. Pyruvate. We've seen that stuff before. But it doesn't turn into the pyruvates that we've seen before. It's turned into homogentisate. The homogentisate gets turned into... There's a couple different things down. There's a couple steps that I'm skipping there, but essentially it will turn into... fumarate and also acetoacetate. Both of which we have seen before. Acetoacetate... Here. Where does fumarate go into? Fumarate is in the TCA cycle, that's right, okay. That's what happens there. Other amino acids. Propionyl-CoA, let's go back to that guy. So, you can make propionyl-CoA not just out of fatty acids. If you eat isoleucine, methionine, valine, threonine, those can get turned into propionyl-CoA. Acetoacetate. We're going back to acetoacetate again. There are many ways we can get acetoacetate. Did I write that down over? Okay, yeah, phenylalanine. Okay, so I wrote down the actual path over there, but phenylalanine, tyrosine. Tyrosine. Leucine. Tryptophan. That's the turkey stuff. Lysine. You eat those will get turned to acetoacetate. Ugh. Alpha-ketoglutarate. You can get it from glutamate, which can go back and forth with a different amino acid. Glutamine. Glutamate. The precursor to glutamate is glutamate semialdehyde. And we can get glutamate semialdehyde from proline amino acid, also arginine. Arginine. Okay. Oh, sorry about my mic. So when we... somewhere in the other steps over here, you end up with a molecule called phosphoglycerate. The phosphoglycerate can either keep going down to phosphoenol pyruvate, or let me like do this instead. So whenever I write the dashed lines, that means there are steps being skipped. So anyway, you can make it out of serine, which is an amino acid. Glycine can also go to serine. Or you can get there from cysteine. And if you're doing that, you have to use... somewhere in here there's also methionine. With semialdehyde, make a nice fluffy rug. Would it? Would it? I guess it'd be a pretty sweet rug. Does that work? It's not sugars though, it's amino acids, so it's proteins. It's all metabolism, we'll just say it works. Okay. No, that's not where all of the... Okay, so oxaloacetate... Did I do this already? Yeah, aspartate. I did it over here, so I'll keep going over here. Is an amino acid. Amino acid. So aspartate, we can get that from an amino acid called asparagine. Everything's connected. Everything is connected. Oh. Okay. Aspartate also goes into the urea cycle. Wait. Yeah. Aspartate can... Okay, yeah. Partate. You combine it with citrulline when you want to make arginosuccinate. It's everywhere. Here, wait, I'm gonna like... Yeah. Everything's connected. Everything comes back together. Everything loops around everywhere. Oh. Oh, it's like a conspiracy nuts corkboard. It's like... It's... literally what's going on here. How does that picture look again? It's like that guy with the crazed look on his face. Like, I have to like look at it. What's he doing with his? One hand is like 3, 4, 5. One hand is just like kind of like touching the board, pointing to the board, pointing at things on the board. The other hand is like, I'll just do like pointing. Bewildered, crazed, conspiracy theorist look. I'm gonna add like bags under the eyes. Okay. Yeah. Yeah. Like that. Like that. Like that. Hair flaps. Bunny ear. Conspiracy theories. There's like big red. I remember there's like big red text on his board that says like Pepe Evil or something like that. Okay, wait. Koi evil. We'll just leave that there. Koi evil. Okay, wait. I need more like. Okay, wait. I'm just gonna like link all the acetyl-CoAs on this board together. Another one. There's another one over here. They're everywhere. They're everywhere. You can't escape them. They're everywhere. Put another one over there, just because, just for flavor. Put another one going behind me too, right there, just for flavor, just because. Yeah. Okay. Cool. Oh, 2 hours. It has been 2 hours. Okay, wait, there's one more point that I want to write on this board, and then I'll go ahead and take a break. I haven't written anything about, like, the nucleotide metabolism yet, so I'll write down the pathway for that, and then I can go ahead and just take a break for an hour or so. So, last thing on the to-do list for now. So, from our PPP, you remember we get ribose 5-phosphate. I love the piano intro to the original, like, Animal Crossing Wild World, not Wild World, but original Animal Crossing population growing. It makes me feel things. That's not it. Ribose 5. Phosphate. Okay. So ribose 5-phosphate turns into okay. It turns into something called PRPP. PRPP. So PRPP can turn into... There's a big long process for that, but we'll just say it turns into nucleotides. If you're not turning it into nucleotides, however, you're really stinking hungry and you need to break down something, anything for energy. You'll end up with 5 phospho ribosyl 1 amine. Okay. IMP. Is that an I or a 1? I think that's an I. Hold up, let me look at the... Let me cross-check the PowerPoint. Purine biosynthesis. Oh no, it's an I. We use more amino acids here. We use more glutamine here. I'll write it in a second. Turns into... IMP. Okay. IMP can turn into XMP or adenosylsuccinate. And so from XMP we get guanine bases, so we get GMP, GDP, GTP, we get our adenosine bases here, so AMP, ADP, we make some ATP. Oh, and they can also be, okay. So, guanine bases can turn into... These will also turn into something. We'll worry about that in a little bit, though. Guanosine? Guanosine? I think that says guanosine? My friend wrote this part of the notes. I didn't write it, and I can't read her handwriting. Guanase? Oh. Wait. No. No, it is guanosine. Okay. Guanosine to guanine, okay. Guanosine, guanine turns into xanthine. Xanthine, okay. And so adenosine bases can turn back into IMP. IMP will turn into inosine this time, though. Hypoxanthine. And then that gets turned into xanthine, and then xanthine can turn into uric acid, which we get rid of. You pee, it goes to the kidneys and you pee it out. Cool. Yeah. There's... Did I already do this? No. There's one more thing that has to do with tyrosine. Okay, fine, I'll write it out. I'll just put it over here real quick. Real quick. One more thing. Real quick. Last thing. Okay. So GTP. Well, we're not turning it into guanosine. It will also go to tetrahydropterin. Terin. It's also called BH4. So tetrahydropterin can go to BH2, and so that goes around in a cycle. And so we couple reactions with these. Let me get my amino acids color. So this one we will turn phenylalanine into tyrosine. And then when we're going this way, this is not an amino acid, we turn NADH to NAD+. This isn't really like... You're just using this molecule over here for energy. It's not like a product that will... It does go other places and do things, but like the primary purpose isn't to make this, it's to use it as energy. Okay. There's... other things here and there, but you know, I guess this is like... This will pass the test. We'll call this like 80%. Exclusively considering like metabolic pathways, we'll call this like 80%. Ugh. Okay, and I think I'm ready for break. Yes, it is break time. Take a break before I break. Okay, let me take a sip of my tea drink. Wow. I have one more ice cream in my freezer. I ate one earlier, and I'm thinking, I also bought that watermelon though, and I was gonna cut that up tomorrow. So I'm thinking, if I want a sweet treat right now, I could eat the ice cream, and then I could cut up the watermelon, and then the watermelon will be a nice healthy sweet treat for tomorrow. What the big brain be doing? The big brain be thinking about getting some snacks in right now. Your brain, you know, only gets energy from sugars, only gets energy from... Well... This would be studying if I explain this. This right here, you call that a ketone body. Your brain uses it as energy. But yes, your brain, for the most part, largely uses sugars for energy. You don't really store like energy fats in your brain. There's not really room for them up there. But yes, I think, I don't know, should I get myself an ice cream? If I eat that ice cream now though, I'm not gonna have any ice cream for later. It's hot too though. That's why I'm thinking about the ice cream. It's a melon ice cream bar. Hmm. I'm thinking of my melon ice cream bar. No spoons. It's an ice cream bar. It's like, it's, can I like show you guys a picture of it? Okay, wait. Let me see if I can find a picture of these things. Trying to find like... I'm looking at like the thumbnail of like a YouTube short, and it's like if somebody like cradling one of these ice cream bars very gingerly in their hands. Let's see if I can find a better picture. It's like a melon ice cream bar. It doesn't look like a melon, it's just green. It's like... Here, I guess this is a good image. Okay, I'll put that there, and then I'm gonna go over here. And then I'm gonna go over here. I'm gonna take this pointer and I'm gonna... I've prepared this and I'm not using it at all. Because I'm just staying inside of Krita and I'm just pointing at things as I need in Krita. Here, let me change this to an ice cream. Let me give myself a sweet treat. While I'm contemplating on whether or not I want a sweet treat, I will change this into sweet treat. Oh. It's tilted. It's tilted. Let me see if I can... transform... Reset. Yeah! It's one of these things! Ice cream bar. Melon ice cream bar. Yumminess. Maybe I will get one. I don't know, maybe I will get one. My brain posted the picture of the lovingly cradling the ice cream. Maybe. I'm just thinking about my ice cream now. Oh, ice cream. Oh, maybe I do want the ice cream. Okay. Maybe I do want the ice cream. Maybe I'm gonna get up real quick and maybe I'm gonna go get the ice cream. Maybe I'm just gonna like... Maybe I'm gonna take my headphones off real quick and then I'm gonna get up from my chair and then I'm gonna walk over here. Can you still hear me? And I'm gonna open my fridge. My freezer, I guess this would be. Can you still hear me while I'm over here? I feel like I'm yelling. I don't want to bother the neighbors. Close the freezer. I'm coming back. I'm back. No. You can hear me? Okay. Did you like Mara gets ice cream from her fridge ASMR? And I'm going to open the ice cream. Mara opens a package of ice cream ASMR. Yay. I don't really like the idea of like eating things on stream, but like I feel like eating ice cream is quite enough. Yay. I got my sweet treat. Okay, I'll take break until I finish this ice cream and then we can get back to it. How's that? How's that sound? Yay. Do you have a favorite ice cream? Do you have ice cream recommendations for me? I feel like I always eat the same kinds of ice creams. It's like, I like the melon ice cream bars, and then like, around like Christmas, like a whole bunch of stores start selling like peppermint ice cream too, and I really like that. And then like, all other times of the years, like, the peppermint ice cream is only sold around like Christmas time, but all other times of the years you can buy like regular like chocolate mint ice cream, so I get that too. There's also like... You know those little like orange ice cream cups? I haven't had one of those in like a really long time, but those are good too. The blue moon ice cream. I'm thinking of like, let me look it up. Blue moon. Is that just like a brand? I know there's like Blue Bunny is a brand of ice cream. Blue moon. Ooh, it's a flavor. I don't think I've ever had this before. Sweet, like marshmallows. With Midwestern USA. I don't think I saw Blue Moon ice cream over here. At least I've never seen it before. I know there's like a whole bunch of like, now if you buy like Ben and Jerry's ice cream, they got a whole bunch of like their own flavors that they have. What else is there? Oh, you don't have it where you live either. Oh, a special treat for travels then. There's like, have you ever had like those little like those taiyaki ice creams where instead of like one taiyaki, like on the inside it'll be filled with like ice cream instead? Those are nice. I like those. Mochi ice cream is, I don't know. Mochi ice cream I feel like is okay, but like, I feel like it gets messy. I feel like it's hard to eat sometimes. I'd rather just have like regular room temperature mochi. Oh, a blast from the past. Bubblegum ice cream and sky ice cream? Sky ice cream? What do I get if I look up sky ice cream? Ben & Jerry's makes a flavor of ice cream called Marshmallow Sky. It looks like the Blue Moon ice cream, except it's got like little cookie chunks or something in it. Oh no, it's supposed to be pecan pie filling. Pecan. Pecans. Pecan or pecan? Pecan? Peakers. There's also like there's also like brands of like not really like sorbet bars, I guess. Like they're supposed to be like, I forgot what brand they were, but they're just like basically like kind of like smoothie kind of sorbet bars. They're good. I like the lemon one and like the strawberry one. It's basically like just blended fruit and frozen, which is nice. Pecan. Say it like toucan. Pecan. Pecan is like a regional thing, I think. It's like, pecan is like one of those words, like if you say it, like people can like tell where you're from. Like whether you say pecan or pecan. It's like, sneakers are like that too. Like your sneakers, if you call them sneakers, tennis shoes. There are people that call them trainers. What else else is there? There are a lot of words like that. They're just like, there's like, I know like, there's like, you can look up like maps of the USA and they'll be like linguistic maps, but they'll show you like differences in like regional dialects and stuff. Wait. USA regional vocab map. I'm gonna look at the Wikipedia article. For American English regional vocabulary. Yeah. What do you mean there are people that call a sub sandwich a grinder? I've heard them get called heroes and I've had them be called hoagies. I have never heard somebody call a sub sandwich a grinder though. Every time I like take a bite out of my ice cream, I like turn away from my mic and I try to like lean away so that you guys aren't hearing as much eating sounds. I hope it's working. Anyway. Faucet versus spigot. Frying pan versus skillet. The gutter versus the rain spout versus the eaves trough? I've heard rain spout, I've never heard eaves trough. Pit or seed? Now hold on, I feel like a pit and a seed are two separate things. Okay, wait. If you were to eat a peach, and you know how there's the seed in the middle of the peach, would you call that a pit or would you call that a seed? You can't hear it? Okay, that's good, that's good. My plan is working. Genius. Perfect. Perfect. No, but if you were to eat a peach, or like a plum, or like a nectarine, or like a different kind of fruit that has like a big pit in the middle, would you call that the pit or would you call that the seed? Cause this says that like pit is like exclusively like a northern dialect thing, but I swear I've never heard anybody say anything but pit. I need to eat my ice cream faster, it's melting. A seed? Seed? You don't call it a pit? Is it just me? Oh. Well, they're both technically right, but like... I guess it is like a pretty common delineation then. What else I got on this list? Hold up. What else I got going on over here? Pail and bucket. This says... Pail or bucket? I've never heard anybody call a bucket a pail before. I've only heard people say bucket. Even like going further up north, I swear I've only ever heard it get called bucket. Wikipedia says that you guys is a widespread saying, y'all is southern, you ones is western Pennsylvania. U's is New York, Philadelphia, New Jersey, and northern Pennsylvania. Oh right, there's also like soda. Do you call it a soda? Do you call it a cola? Do you call it a pop? Tonic? I don't think I've ever heard anybody say tonic before. You always thought a pail was a very small bucket? I can see that. Like a pail, like a sand pail, like if you buy like a small child, like some sort of like sandcastle making kit. Like I would call that a pail also. I would also just call it like a bucket too. Like in terms of like what I would like instinctually call it, I think I would still say bucket for that though. Breezeway? I've never seen, like, you know, like bridges connecting two buildings? I've only ever heard those referred to as like sky bridges. I've never heard them called a breezeway, and I've never heard them be called skyways. You called it soda, soda pop. I've also usually heard it get called a soda. This says that firefly is more of like a northern and western saying, and everybody else says lightning bug. Finished my ice cream, but it melted on me a little bit. Soda, soda, refresco. Yeah. Soda, soda. I guess soda is like the most like widespread one. Oh, you call it a firefly and your cousins in Wisconsin call it a lightning bug. Wisconsin. Wisconsin is still pretty west though, I feel like. Like when this Wikipedia article says west, like how west is west? Do they mean like literally just like West Coast west, or is it like because it also says more northern too under Firefly. Wisconsin is like as north as you get. Fascinating. Fascinating. They got like listed under like northern sayings. I would call that more like just a generally kind of Midwest saying though. What else they got in here? Apparently it's New England folks that are calling sub sandwiches grinders. Grinders. I've never heard that. It says sneakers is a Northeast saying. But I say sneakers. I've never lived on the East Coast. Under Northeast, it says steamed ham, an alternate name for a hamburger predominantly in the area of Albany, New York. You hear that? It's an Albany expression. I don't think that's real. I think somebody's being a prankster over here. Unless people actually started calling them steamed hams after that Simpsons episode aired. Steamed hams. I could go for a good steamed ham. Aurora Borealis? In this part of the country at this time of day. Localized entirely. In my kitchen. In your kitchen? In our kitchens? Perhaps? Wasn't there like some months ago there's actually like that event where you could have seen like an Aurora Borealis if you're like some of like the northern states? If you're like Canada or some of the northern states. I want to see Aurora Borealis. I think it'd be cool. I think it'd be cool to see to have a little Aurora Borealis in my backyard in this part of the country, you know, at this time of day. Apparently another one like happened like 50 or some years before that too, so I guess like, I don't know, I could just be saying stuff though. It's just things I heard from word of mouth. I don't know, maybe another one will happen in our lifetime. I think it'd be cool. Aurora Borealis is the northern lights, and Aurora Australis is the southern light. Oh, whoa. So it'll just be like Aurora then. What would we call it? Like Aurora in the Middle-ialis? Aurora Equatorialis? Like the equator being between the equator and Australia? We'll just say Aurora. Aurora Borealis! You could see it outside of the poles, like some months ago. I forgot when, but like if you were in like Canada or some parts of like northern USA, supposedly you would have been able to go out into your backyard and look at the sky and say, "Whoa! Look at the colors! Beautiful! Vibrant! Gorgeous!" Under Eastern New England, it has frappe listed as another word for a milkshake, but I've only ever heard frappe get used in like coffee shops to like refer to like blended ice drinks. Like you go in and you ask for like a mocha frappe, or you ask for like a matcha frappe. I've never heard it get referred to like for a milkshake. It's always like some sort of blended like barista made drink, I think, over here. Jimmy's? Have you ever heard anybody call sprinkles Jimmy's? You only know that frappe, yeah. I want a scoop of chocolate mint, I want a scoop of Rocky Road, and give me some Jimmy's on top too. Jimmy's? I want some of them rainbow Jimmy's. Jimmy's. Leaf peepers. Oh, is there one for like if you call like Bigfoot versus if you call Bigfoot Squatch? Let me see. I don't see any. Aw, I don't see any. Wait, do you guys say Bigfoot or do you say Sasquatch? I think it's funnier to say squatch. I like it when people talk about like going up into the mountains and like taking their cameras with them and going looking for Bigfoot, and they call that like squatching. I like that. I think that's a fun word. How do you say that? Pia Grande? Another word for squatch. Oh, most people know about Aurora Borealis, but they don't know Aurora Australia, the Australis. I know that they were like Southern Lights, because I mentioned this before, but I ended up like following like this one guy. They're like, I found like the blog of like this one guy that was like, he was like an IT worker in Antarctica. And so I would read his blog from time to time, and like he ended up writing like a blog entry on like the Southern Lights, and so that's how I found out that there are Southern Lights as well as Northern Lights. I didn't know before then though. It's a fairly recent development for me. Oh. Pia is foot, Granny. Oh, okay, so Bigfoot then. Bigfoot. Not Squatch. I don't know, maybe Squatch is a regional word. Wait. What if I just straight up look it up? Sasquatch, regional word. Regional Bigfoot names. That's what I'm looking for from whatisbigfoot.com. I click on the link and it shows me a picture of Squatch giving me a really hard stare. This says, oh wait, no, I'm thinking of something else. Cherokee Devil, Florida Swamp Ape. Wood Booger? Oh, the Bennington Monster in Vermont. There's Squatch all over the USA. Everybody's got their own Squatch. The Ape Man. Little Egypt Monster. The Grass Man is what they call him in Ohio, particularly in the East. Fascinating. Various tribes apparently just call Sasquatch the hairy man. Sasquatch, though, is like a native word, I think. What does Sasquatch mean? Okay, wait. What does Sasquatch mean? It comes from a Salish word meaning wild man. Okay. Sasquatch. There's like other they got Sasquatch theories. They got a section of the site for photos. They have a section of the site called Strangeness. What is this? Oh. The strangeness of Bigfoot, more than just a legend. It's got like a list of like 22 strange things about Sasquatch here. Wait, I'm gonna go through this real quick. They say some people report that Sasquatch has big glowing red or yellow eyes. Some people say that Sasquatch is ungodly stinky. Some claim Bigfoot can vanish into thin air, leading to theories that it's interdimensional. The Bigfoot dimension. Bigfoot can mimic human sounds. Bigfoot is a skinwalker? Bigfoot has a connection to UFOs. Bigfoot is an interdimensional space traveler? It's Chewbacca. It's Chewbacca. He's there in the woods. Wait. Bigfoot can build stick structures and glyphs. Bigfoot Sasquatch mind speak ability. Gigantic but incredibly fast, different amounts of toes or feet. Throws rocks at people? Squatch throws rocks at people? Oh wait, I didn't write a warning on the screen that I'm taking a break right now. I just realized. That's okay though. That Squatch can swim and cloak itself like a predator. Leaves footprints that suddenly stop, as if Bigfoot vanished or took off into the sky. He could fly? Is he flying or is he just jumping very high and very far? I think that's an important question to be asking too. Possibly uses infrasound to stun or scare people. Attracted to sounds of music. An appreciation for the fine arts. I see. Sometimes walks on all fours, feeling of being watched. Bone-chilling, earth-shaking screams. Strange lights and Bigfoots. Strange orbs of lights are often associated with Bigfoot sightings. Spider crawl? Belly crawl? Bigfoot has a stealthy crawl? They gotta sign up for our newsletter. Section of the site on here too. What do you mean worldwide Bigfoot names? Worldwide? Oh wait, what's the one that's like... The Yeti? Oh wait, no, they do have Yeti in here, okay. A variant on Bigfoot, perhaps? It's like, I don't know. When you're talking about Squatch, how specific are you getting? Because I don't know if I'd count the Yeti as like a Bigfoot. Maybe Bigfoot adjacent, but I don't know if I'd count the Yeti as like actually Bigfoot. I might count them as different. It's like saying any dog-like creature is the same. It's like taking a coyote and a wolf and just a regular house dog and saying these are all the same animal. That's what I feel like this is like. I don't think they're truly as dedicated to Squatch as they say they are on this side. I think they're just looking for clicks. I don't know if I trust them so much anymore. The picture of Squatch they got on this page is kind of creepy. I don't like the way his eyes look. It's kind of weird. It's kind of freaking me out. I think I'm gonna close the tab. Okay. I think we're done with Squatch for now. Anyway. Too many powers for an OC. Squatch is somebody's Mary Sue. He's just like all power. No, but he's got a debuff. He's got the social anxiety debuff. Squatch is just like he's just like the anime main character. Kind of like sinks into the background. He kind of like just disappears and does his own thing. He's like in the pre-anime stage where he's like in that kind of like pre-anime stage where he's like doesn't have any friends yet. He's like thinking about how alone he is, but like one of these days we're gonna find Squatch. We're gonna find Squatch and we're gonna like Squatch is gonna be like surrounded by friends. gonna cover up the wrapper so you can just see the ice cream bar. Anyway, I feel like that's where Squatch is in his anime arc. Anyway, we're done with Squatch. Another thing about Antarctica is when people think Antarctica, they think blizzards. That's where people think about the Arctic, they think about the Northern Lights and Santa Claus. That is true. I don't know. I also feel like when people think about like I feel like people think about like exploration and like blizzards, like regardless of whether you're thinking about North or South Pole. It's just like there's more like that association with like Northern Lights, Santa Claus, mystical, magical things when you go to the North Pole. It's like, what's in the South Pole? There's penguins down there. March of the Penguins. It's more scientific down the south, I think. There's no Santa Claus. It's like March of the Penguins research base down Antarctica. Squatch is like a brown recluse. They're hard to find to take up but if you do, they will make you pay dearly for it. Squatch is not like a spider. I wouldn't compare Squatch to spiders. Squatch is... I don't know. Are there a lot of stories of like Squatch attacks? I feel like there's not. Wait. Sasquatch attack. I'm gonna Google Sasquatch attack. Squatchable.com, wait. A chilling survivor's account of Bigfoot attacked at Pinecrest Summit 2025. Oh, a chilling encounter with Sasquatch. Sasquatch attacked me in Glacier Park. Michigan man claims he was okay, maybe there are a lot of Bigfoot attacks. 1924 Ape Canyon incident. Where is this? Oh, this was in Oregon. Man says Sasquatch attacked him with an axe. With an axe? If it was with an axe, I don't think that was actually Sasquatch. I think somebody might have been wearing a costume there. Brown recluses have necrotic venom. Yeah, it's gross, so... It's supposed to be, like, really painful, too, right? Ooh. I don't think Sasquatch has venom, though. He's got those big old teeth, though. Maybe a roach when you turn the lights on? Well, I think Sasquatch would be a little bit more dangerous than a roach. I don't know. Maybe the brown recluse... Maybe the brown recluse analogy is apt after all. By the Squatchable.com staff. Let's see. January 3rd of this year at Pinecrest Summit. But where is Pinecrest Summit? Where is Pinecrest Summit? Oh. I don't think this is a real video. I don't know if I trust Squatchable.com. I think they might be using AI to make fake Bigfoot news. I don't know. That's just my thoughts. I don't think they're truly dedicated to Squatch. I think Squatchable.com might also just be looking for clicks. Oh, this is from the New York Post. Okay, wait. Let's see. That doesn't look like a real Squatch. That looks like a man in a suit. Squatch crossing sign. Yeah. Captured in viral clip is a scary. So that doesn't even look like a. There's no emotion on that face. The face isn't moving at all. It looks like a costume. It doesn't look like a real Squatch. It doesn't look like Squatch. How much do I like Bigfoot? Not as much as I like Mothman. I think I like Mothman a little bit more than I like Bigfoot, because Mothman is supposed to be like explicitly like amicable towards humans. Squatch has some anger in him, it looks like. There's a town in Alaska called Portlock that is supposedly home to a Bigfoot-like creature. Oh, it's abandoned. Let's see. String of mysterious deaths and disappearances. The early 1900s into the 1950s. Mothman? You don't know about Mothman? Mothman is like from like West Virginia. Mothman? He's a man? He's also a moth. He's Mothman. Wait, I'm gonna open up the Wikipedia page because I feel like Wikipedia would be able to explain things much better than I could. Okay, yeah. Yeah. First sighting reported in 1966. Couple see man-sized bird, creature, something. And national press soon picked up on the story. Thus, the people learned about Mothman. Mothman? I think Mothman is supposed to like warn people of danger before it happens. Yeah. Mothman tried to warn the people about the 1967 Silver Bridge collapse. Mothman. He appears before disaster. He tries to warn the people. Mothman says, "Get out of here. It's dangerous here. Get out of here." How do I know what Bigfoot looks like? Everybody knows what Bigfoot looks like. Everybody knows what Squatch looks like. He's famous. I don't know. I feel like it's fairly easy to tell like a real Squatch face apart from like a plastic Squatch mask, too. A fairly simple task. 55 Mothman sightings in 2017. Mothman was busy in 2017. What was going on in 2017? What else do they got here? Oh, right. Mothman Festival in West Virginia. Yeah. Do I want to go to the Mothman Festival in West Virginia? I think about it from time to time. I don't know. I feel like it might be kind of gimmicky, though. Same as like those little alien festivals and stuff like that. It's like less for like enthusiasts and more for like people who are just like want in on like the novelty of like a cryptid in the area. Mothman has two sides. You can view the film. Either they cause a disaster to happen, or they show to warn of an impending disaster. Oh, that's true. That's true. I don't know. I kind of prefer like the interpretation that Mothman is there to warn of the disaster, though. What else do they got on this Wikipedia page here, too? Giant owl man. Snowy owl man. Mothman. Yeah. What if I go to like the Wikipedia page for Mothman disambiguation? Not to be confused with Owl Man. Oh, man. Who lives in the United Kingdom. Mothman is American and Owlman is Mothman's British cousin. We'll say that. Let's see. Is there like a cryptids page? There probably is a cryptids page. How do I get there from Mothman, though? See also, West Virginia cryptids. Apparitional experience. Belled buzzard. What's this? Fearsome creature. An omen. The boogeyman. Cryptid towns? Mothman Museum, whoa. Yeah. Many creatures in this great wide blue world. There was a sci-fi film made in 2010 called Mothman. Is it actually about Mothman, though? Wait. It was a horror movie. It was a sci-fi film too, so you gotta question the quality of this thing. It's the same people who made Sharknado. Let's see. Oh no, it is just about Mothman. Oh, Mothman is evil in this movie. What do you mean Mothman is coming out of the TV like the girl from The Ring? What do you mean Mothman is planning on taking revenge on the entire town? For what? For what? What did they do to piss off Mothman? Alright. Mothman movie. Let's see. 2017 documentary film The Mothman of Point Pleasant. 1975 book called The Mothman Prophecies. 2002 film called The Mothman, based off of The Mothman Prophecies, also called The Mothman Prophecies. Mothman, not Mothman, but member of the Watchmen Mothman, is part of DC Comics universe. Moth Monster Man. A character in a TV show called Aqua Teen Hunger Force. What is that? Oh. Okay, I see. I recognize these guys. Okay, I just don't remember what they were called. Okay. Yeah. That's enough Mothman for now. What time is it? How long have I been taking a break? It's 11:30 now. I should probably get back to studying. Okay. Back to studying for me, I suppose. How long Oh, I don't have much longer on this Animal Crossing playlist. Another Animal Crossing playlist I can... This one is a 4-hour Animal Crossing City Folk playlist. I don't know, though. I kind of like just the mix of, like, different animal... Is there, like, a general Nintendo music kind of playlist I could put on? It can't just be, like, an hour, though. It's gotta be, like, really long. Nintendo music to work to in the morning. Or 2. It's not morning, though. I don't know. Maybe I will play that one next. Okay. After the Animal Crossing music is over, we will go to Nintendo music. General Nintendo music. Less time than the last time. Okay. Well, that's good then. Self-control is being practiced here. Okay. I'm gonna... really quickly before I get back to studying, I'm gonna go There's a little bunny's room real quick. So let me take this, and then let me go over here. I'll make that bigger. I'll make this smaller again. And then we'll go. She's in. She's in the little bunny room. BRB. Okay. And then I'll go over here. And then I will be really quick. I will be back. I will be back, and then we will continue studying. I will be back. Okay. Refreshed. Rejuvenated. Ready to study once more. Okay. So let me get all my windows sorted out again. I'm gonna take this. I'm gonna put this. I'm gonna get rid of this. Okay. Okay. You see, everything makes sense with how it fits together. I just have to get all of this in my head and memorize what goes where. Okay. Anyway, that is all of that sorted out. So I'll try and run through that again real quick before the end of the night, but also next I'm gonna go through all of the metabolic disorders that I need to learn. So there's a document that has been put together with these things on it. So let me open it up real quick. Here? Yeah. Open this up, and then I put that. I'll put this. Okay. Okay. Will I teach you guys that so I can remember what's the strategy? I'm gonna. If I try and teach you guys, I feel like I'm just gonna end up reading off of this document over here, so I might just I'll run through them all. Sorry, I just bumped my desk a couple times again. I'll run through them all, and then maybe I'll like quiz myself a couple times. Like I'll just like put the names on a document and I'll run through them and try to get them all through my head. Okay. Okay, wait. So let me move some stuff around over here. Let me try and get... I'm gonna put this over here, and I think that's good. I need more desk space. I don't have a lot of desk space. Okay. I think that's fine right there. Let me move that over there. Okay. Alright. I guess I can just move down through these. Actually, I haven't written down any of a lot of the enzymes here, have I? So maybe I should go back and put those in real quick. A lot of them, though. Okay. So... did that, and I did that. Okay, so... if I put this here, then I can't get to my keyboard. Okay, wait. So let me move this over here instead, actually. I'm gonna move this back to where it was before. Which is down here. Oh, this over here. Okay, and then, let's see. So... enzymes first, and then diseases. So I wrote PFK1, PFK2. Okay, so this is when we make phosphoenolpyruvate, we use an enzyme called pyruvate. Wait. No, yeah, phosphoenolpyruvate. Okay, next step. Phosphoenolpyruvate to pyruvate. This is pyruvate kinase. And then when we turn pyruvate into acetyl-CoA, then we use... well, it happens inside the mitochondria, so let me write this over here. Pyruvate dehydrogenase. The music is over. The music is over. No. Let me. Okay, I'm putting on this Nintendo morning playlist. Yeah, okay, I guess this is an okay playlist. Wait. No, this is just a 30-minute playlist that loops for like an hour. Wait, I'm gonna put a different one on, man. This one's not long enough. What was that other one I was looking at earlier? Where did that go? Where did it go? I don't just want to listen to the same playlist on loop for like 3 hours. Okay, wait. I'm putting this one on. Yay! What's the first one in this song in this playlist? Disc channel from the Wii Fit Plus soundtrack. Then we're going into the Mii Maker music from the Wii U. Okay, now this is a good playlist. Okay, this is a good playlist. So yes, that is pyruvate dehydrogenase. I need the glycogen pathway gluconeogenesis. No. Yeah, glycogenesis and glycogenolysis. Gluconeogenesis goes up to here. And then glycolysis goes to pyruvate. Okay. So glycogen and glucose 1-phosphate, that is glycogen phosphorylase. Glycogen phosphorylase, wait, is that right? Where is the PowerPoint? I might need to double check with the PowerPoint again. Okay. Nitrogen goes. Okay, so this goes to that via phosphoglucomutase. Okay, and then we end up with glucose 1-phosphate. Yeah. Okay, now so going through is glycogen synthase. Glycogen synthase, so when you take that off, there's a couple different ones that take them off. Okay, I see. But we'll say the main one. Glycogen phosphorylase. Okay. And then does phosphoglucomutase also go back to I guess it does. So yeah, call that good right there. Okay, then we'll go over here. This will be... No, not over here. Over here. So you... we'll do this. You add in a coenzyme A, and then you also shove them through acyl CoA synthetase. So that is the enzyme there. Do I need to know the... Do I really need to know the amino acids for that? It's hard to tell sometimes. Okay, no. Okay, I think I can just run through things, and like where I'm missing things, I'll just fill them in as they come up. Okay. These are connected somehow, actually. Let me go over that real quick before we go on again. time I go back into the notes, there's even more. It'll be okay. It's okay. Okay, I'm just gonna start going over disorders. Okay, we'll just start in the sugars, I suppose. I should use a new color. So I haven't used yellow yet, so we'll go with yellow. Okay. So, if we start all the way at the beginning, you eat glucose, there's beta cells of the pancreas, I believe. Even out. No, it was beta cells. Okay. So beta cells of your pancreas make a something called insulin. So for your cells to use glucose, they first have to know that there's glucose in your blood, and so there's a couple different ways that they can sense glucose. First is when your pancreas makes insulin, insulin will like bind to like gated, like, to simplify, basically like gates, not like gates, but like transporters on like the cell membranes, and they like tell them, hey, open up, there's glucose outside, go bring it inside. And so they'll do that and they'll bring the glucose in. And so in type 1 diabetes, your immune system attacks the beta cells of the pancreas, so there is no insulin. And so the cells can't take in glucose, and that's how that reacts. Type 2 diabetes is insulin resistance, and so it's like if sugars are like they talk to the gatekeepers. It's like no, it's like it is the gatekeeper. And it's coming back to like its post to open the gate and like let things through the gate. To simplify, I guess. Like, yeah. It's like there's nobody there to like operate the gate until insulin gets there. So, anyway. Type 2 diabetes would be insulin resistance. So you're still making insulin. You still have your beta cells in your pancreas, but like sugars are so consistently high, like insulin is always coming to the gates that the gatekeepers that are already there at the gates are saying, hey, you were here just a little while ago. I don't need to listen to you. We did this just a little while ago. And so they're not listening to signals like they used to, and so even though there's insulin, the sugars still kind of build up like that. Again, this is like a simplification. There's like a lot of like downstream things that are happening where like it's not like at the gate, it's like more downstream that the resistance happens. Like not in this path, like it's a completely different path, but yes, that's how that happens. Then there's a third type of diabetes called mature onset diabetes of the young. Mature onset diabetes of young, and this one doesn't have to do with insulin. This is more like glucose sensing via hepatic nuclear factor 1A as it acts on glucokinase. It is. This third one is like a newer discovery. Yeah, it's not. Let me. What was it? Okay, wait. Mature onset diabetes of the young. How would this be classified? Was discovered in let's see what the National Center of Biotechnology Information has to say. Oh, it was discovered in the 70s. I guess there's a lot of different types of diabetes. Type 1 and type 2 are just the most common. Okay. Well, that's going down a tangent that I don't need to know. So, okay, wait. So, yeah, anyway, I wanted to look up hepatic nuclear factor 1A. I wrote down hepatic nuclear factor 1A and I wrote down glucokinase, but I don't know if like the nuclear factor works on glucokinase or if there's like two different paths here at play. So I'm trying to see. I could also just look and see if I can find. Okay, wait. Not sure what this be in. Okay, here it is. Mature onset. Okay, no, they're separate. Okay. So this one is not related to insulin. Instead, it's related to hepatic nuclear factor 1A or your glucokinase is not picking up glucose as it should be. So that is another type of diabetes that may be had. So this one is more like type 1 diabetes in the sense that it's not something that you can develop over time. You're either born with it or you're not. I need to know like genetics of disorders too. So this one is autosomal dominant. So for autosomal traits, you like get, there's like two halves of the gene. One comes from mom, one comes from dad. And so like usually there'll be like, we'll say like there's a variant of the gene that's like yeah, we'll say like big A is like the normal variant of the gene, and we'll say that little a is the no, actually, let's say that big A is the variant of the gene that results in the mature onset diabetes, and little a is the gene that results in yeah, the gene that results in normal non-diabetes state. So like if it was a recessive gene, then you would need like two of them to result in the diabetes state. Like if you had like a gene like this or like a gene like this, you wouldn't have diabetes state, but it's autosomal dominant instead. So like as long as like as long as like the diabetes gene is present in some fashion, so you could have it like this or you could have it like this, and then you will have the mature onset diabetes of young, unless you have 2 copies of the normal gene, in which case you would be safe. But like, in this case, if you have at least one parent with the, well, no, never mind, actually, scratch that. But yes, autosomal dominant is the inheritance mode of that trait, and so that is one of the diseases on my list. Another one is, let's move down to fructose metabolism over here. So there is an enzyme right here called fructokinase. There's also an enzyme down here called aldolase B. So mark this with a 1. This one is 2. So there are 2 types of fructose metabolism disorders that are common to have down here. The first one is essential fructosuria. Essentially, the fructose goes in, but because this enzyme right here isn't working, you can't digest it, so you just pee it all out. It doesn't really do anything to you, you just have like really fructosey pee. Which is, you know, it's not dangerous, so it's okay. So this one is autosomal recessive. Most of these disorders are autosomal recessive. I think like mature onset diabetes of the young is kind of like unique in that like very few, I think that might be the only autosomal dominant disorder that I need to know. Down here and over here, I believe there are some specific to the mitochondria linked to like XY chromosomes, X-linked disorders down there. We'll get to that later. Anyway, essential fructosuria, autosomal recessive. It doesn't really do much, so we'll just say benign. And then other fructose disorder you can have is fructose intolerance. This one is more dangerous. I believe it's also autosomal recessive. Yes. So this one, fructose 1-phosphate must like, I guess like it must have some sort of like effect on this pathway over here, because fructose intolerance will like lead to like hypoglycemia, so like high blood sugars. It can cause like liver damage too, so you end up with like jaundice or cirrhosis of the liver. And like, but it's like episodes onset after eating like fruit and like honey, juice, other things with like fructose in them. What do my professors have to say about this? Fructose intolerance. Show me more about it. Oh, I see. Okay. So it's not that this has a direct effect on this, it's more like fructokinase is still running, so you're using up all of your phosphates over here instead of using up all of your phosphates other places, and so like these get all backed up because there's not enough phosphate. And so that's where the hypoglycemia comes from. This is not running forward because fructokinase is using up all the phosphate, and so these can't proceed. So yeah. Mostly oh, because aldolase B is also involved in these other steps down here. Right? Yeah, oh wait. No. Yeah, all of this is part of the other steps. No, I remember now. Okay. All of this is glycolysis steps, so like actually let me like take purple over here. Yeah. And we'll just like do like this. Those are like glycolysis steps. Okay, so yeah, aldolase B isn't working, so you can't do any of this, basically. So this all gets backed up. This gets backed up, this gets backed up. The liver damage part would be... You're not making... Acetylco... No, there's fructose somewhere else here, I feel like. Fructose can also go to... Oh, if fructose is backing up, it gets turned into fructose 2,6-bisphosphate, which... acts on... No, fructose 2,6-phosphate tells the cell that it's in a low energy state, which should... I'm trying to wrap my head around the liver effects. Alcoholic... No, wait, no, not alcoholic, but like... liver damage. Liver damage. At any rate, here. We'll just say autosomal recessive. Liver damage. Hyperglycemia. Here's my notes again. Hyperglycemia. And you can treat episodes when they happen, but like you kind of just gotta like... restrict fructose from people's diets to prevent them from having episodes in the first place. If they have fructose intolerance like this. So you treat it by restricting fructose from the diet pretty much. So those are those down there. If you remember galactose up here. There's also a couple of galactose digestion disorders. So... and over here... this would be galactokinase. This one is... oh, it's long. This one is... galactase 1 uridyl transferase. Blech. Okay. So you can have one that happens up here and then one that happens down here. So number 1 I believe is... yeah, oh, number 1 is mild. Okay. Number 1 is mild galactosemia. It's autosomal recessive, and so it causes galactose to build up in the blood, which leads to like cataracts and also developmental delays. Okay, so it's usually caught like pretty early on too, so infant cataracts. And then missed developmental landmarks. So the examples listed here are like tracking objects with the eyes, and then social smile as well. Okay. So there's not really much you can do about this either. You just kind of gotta avoid like giving lactose in the diet. It'd be hard for a baby, I would assume. Okay, so number 2 would be classic galactosemia. No dietary galac. So classic galactosemia is also autosomal recessive. If this is not working causes... what is... to tell us this one? Okay, so if you're not making this, galactose builds up and instead becomes a substance called galactitol instead, which is toxic. You see, if the body is not working properly, it just panics and starts making poisons. So the buildup of galactitol. So there's similar symptoms here. You also have like the cataracts and like the developmental delays. This one... You end up with liver damage in this one, too. Liver D. And then you treat it the same way you treat mild galactosemia. You just avoid giving baby galactose and lactose. So I'll say diet restrictions. Okay, and that's how you treat that. So those are the disorders that can happen with galactose metabolism. If you have too many fatty acids, you end up with fatty liver. I don't think I need to know the pathway for this. So just remember that that happens there. Those are too high. Let's keep going down. Okay, down here. Pyruvate kinase. If pyruvate kinase is not working, it gives you... It destroys your red blood cells. There's another way that you can get hemolytic anemia. It has to do with over here. It's if... What was that enzyme called again? Yeah, okay. So... From here to here is glucose 6-phosphate dehydrogenase. And so if your glucose 6-phosphate dehydrogenase does not work, that has a couple of downstream effects. This down here is like its own whole big cycle with a whole bunch of other reactions, like couple to reactions down there. So throughout the metabolic process, there's lots of opportunities to end up with like reactive oxygen species. So it's just like high energy oxygen molecules that are just like made as waste products sometimes, and you don't want them floating around because they can damage things and possibly give you cancer and all of that bad stuff. So your cells have ways to deal with them, but like when glucose 6-phosphate dehydrogenase is knocked out, that knocks out one of the ways to deal with them, and so they kind of build up and they cause a lot of damage. So you get hemolytic anemia here too, because your ROS will build up over time. The reactive oxygen species will build up over time. So for the most part, you won't experience symptoms unless like yeah. Can avoid symptoms as long as you avoid oxidative stress. Symptomatic. Avoid oxidative stress. There's certain foods that you can eat that increase oxidative stress. It's like, I think like fava beans? Is that it? Let me like see if I can find Professor's slide over here. Yeah, fava beans. You gotta avoid like certain medications too. Oxidant drugs such as antibiotics, anti-malarials, and antipyretics, so anti-fever. Okay. So oxidative stress. Fava bean. Antibiotics. Anti-malarials. Antipyretics. Yeah. And then, good thing you don't eat fava beans. Well, if you don't have the condition to begin with, then the fava bean is not such a big deal. It's just if you have this genetic disorder, then maybe avoid fava beans. You should know you have it pretty early on if you do have it, though. Like a lot of these metabolic disorders, like for the ones that have like pretty like striking effects, like since they're there from the time you're born, like since you're feeling those effects from the time you're born, like they get caught pretty early on. So yeah, if you have an episode, you just like treat it symptomatically. You like give them like blood transfusion to replace all the blood that was lost or blood that got destroyed in the episode. Yeah, give them oxygen. Just wait for them to stabilize, basically, which is not fun, but not really much else to do. It's so bleak. A lot of like these metabolic disorders, it's just like you can't really do anything to get rid of them because they're like genetic disorders. It's like, so you just gotta kind of like tell people like, you know, avoid this, avoid this, avoid this. If something happens, then we'll deal with that when it happens. I don't know. It's nice that like, I think it's nice that like there is like headway being made into like gene therapy, so that a lot of these disorders and a lot of like childhood cancers too like have like pathways that they can be treated through. Starting to have like methods that they can be treated through. So yeah, that's that. What else do I need to know over here? Okay, let's go back to pyruvate. So there was pyruvate kinase. If you're deficient in pyruvate kinase, you end up with hemolytic anemia as well. Pyruvate dehydrogenase. If you are deficient in pyruvate dehydrogenase, this is not autosomal recessive. This is an X-linked recessive mitochondrial disorder. So X-linked recessive. Can't make it better if it's genetic, but you can stop it from getting worse. Yeah, basically. I don't know, maybe one of these days, I honestly feel like as long as we keep working on it, it's not that far off, like a day that like we can like cure like genetic disorders like these. A day where like cures will be like accessible and like affordable to people will probably be a little bit further off, but like in terms of like actually getting the technology there, I feel like we are rather close. So if you have this, you end up with neurological defects. Lactate acidosis. So lactate... Oh, because lactate can turn into lactic acid, and so that would build up, and that would make the blood all acidic. Okay, I see. And it makes your alanine go up, too. So... it makes alanine build up in the blood. Not blood, alanine. Serum alanine goes up. Where are my professor's slides for this? I didn't write down a whole lot for this. It's probably over here. Wait. 6-phosphate dehydrogenase deficiency. I don't know pyruvate dehydrogenase deficiency. Pyruvate dehydrogenase. That's not what I'm looking for. Perhaps here? No, perhaps here. Pyruvate Oh, weed noise. Okay, but I'm looking for pyruvate dehydrogenase. Where is it? Where is it? Where did I get the... Wait, do I gotta go? I guess I need to know. Well, I need to know cofactors, but that's related to vitamins. I guess I can go over that later. Maybe it's over here? Pyruvate. No, there it is. Dehydrogenase deficiency. Okay, pyruvate dehydrogenase deficiency. Okay, so did I write that down here? Okay, no, I didn't write that down. So pyruvate can also get turned into lactate. It can also get turned into our friend alanine, the amino acid. You remember him. He's shown up a couple of other places too. I think. Or am I thinking? No, I was thinking of aspartate. Wait. No, alanine I feel... It's over here. Where did I see alanine again? Where was it? Oof. Oh, no worries if you fall asleep. Whatever you need, whatever you need. I say this a lot, but I truly mean I want you all to watch however is most comfortable for you, and if that means putting me on as sweet and sultry sounds to lure you to sleep, that is all fine by me. Okay. I think the Nintendo music I got going on in the background too is also rather relaxing. Okay. So yeah. Alanine goes up, lactate goes up, which increases lactic acid too. Neurological defects. I guess it's just because you can't turn sugars into ways that they're usable with the brain. Anyway, that's that. What else is here? I connected all the acetyl-CoAs as like a joke, but actually it's kind of helping me. Fatty acid, beta oxidation, ketone body formation. That's beta oxidation, which is fatty acid metabolism. This is ketone body formation. This is the main ketone body. Anyway, if your ketone body's like... Oops, sorry. If your ketone bodies build up, they make the blood really acidic, which causes problems and like possibly leads to like coma and death. It's a worry in type 1 diabetes because like the body has like a lot of sugar, but like the body can't use any of the sugar because none of it's because like there's no insulin to like bring it into the cells. So like instead of like going down the regular like glycolysis TCA cycle, oxidative phosphorylation energy pathway, it kind of, the body like assumes that it's in like a starving state instead. So it starts going down like different pathways, especially like fatty acid breakdown instead. And so you end up with a lot of like acetyl-CoA going to down this acetoacetyl-CoA down to this HMG-CoA and then down to the ketone body formation path over here. And so yes, that's how that happens. Next study stream, calm music and everyone falls asleep after 2 hours. You see? I'm keeping it nice, calm, and cozy in here. I'm very particular about the vibe. The vibe is calm and cozy and low-key enough for you guys to start falling asleep, you know? You know? That makes me happy. That's what I'm going for. I'm gonna like... Just gonna like... I gotta put my clothes on. Okay, cool. I have clothes again now. My ribbon. I almost forgot something vital. Okay. So, this is the predominant ketone body in the body, though. So let me go. So, the ketone bodies are good for things. I think I mentioned this earlier, but they don't just stick around your blood and make it all acidic and send you into a coma and eventually kill you. They are like, under normal circumstances, they go up to the brain and the brain uses them as fuel. But yeah, if there's too many of them, you end up in a diabetic coma. I need to know the amino acids for this. I don't think I do. There's no disorders in my professor's PowerPoint about that, so I think it's fine. I'll just leave that for now. Okay, there's some disorders going on in the PPP over here. Triple P. Oh, I already had the... Besides the hemolytic anemia associated with, like, the glucose 6 dehydrogenase there. Wait, am I looking at the... Oh no, I'm looking at the wrong path. I wanted to go to... fatty acid, beta oxidation over here. Fatty acyl-CoA... Yeah, the fatty acyl... Okay, wait, actually, let me, like, do this, and then, like... So fatty acyl-CoAs get, like, packaged up into the with triglycerols, and that, like... Make a note here. Package with... That's a G. Triglycerides, and then you end up with a bad cholesterol that sticks around in your blood and forms plaques and gives you heart attack, stroke, all that fun stuff. Okay. So, fatty liver there. If you go down here, there's an enzyme down here. The fatty acyl-CoAs exist in the cytosol. And then this is the mitochondria. So there's a couple different transporter enzymes that make up the carnitine shuttle. And this has to do with a vitamin deficiency as well. I'm gonna have to look that up. But if the carnitine shuttle is not working, you end up with hypoketotic hypoglycemia. So hypoglycemia is low blood sugar, and then hypoketotic, I assume, means you're not going to the You're not going down this pathway either. Okay, wait. Let me see. Glycogen storage disorders. Haven't I already done that? Oh, I haven't already done the glycogen storage disorders. Okay. I think I'll do that next then, after I figure out what's going on with the carnitine deficiency over here. Maybe it'll be under the vitamin deficiency section, actually. Okay, wait. Carnitine. I guess not. So it's related to... It probably... might be over here? Oh no, it's over here. Deficiency. Okay, so it's not a problem with the actual transporter itself, it's more just a... Oh no, it can be either. Either you don't have enough like carnitine itself, or you don't have enough, or there's something wrong with the transporter enzyme and it's not using up carnitine. Okay. You end up with hyperammonemia though, which... Okay, wait... No. Hyperammonemia, so... No, there's another pathway going on here that I'm not looking at. So it increases the ammonia in the blood. Why? But why? Alright, well... The anemia in your blood goes way... Ammonia in your blood goes way up. It also has like liver and heart problems. Okay. Is this a Zelda song? Where's this from? Oh no, this is Garden of Hope from Pikmin 3. Oh. Okay. Okay. So... just leave that as that. I think that's good enough. This is autosomal recessive, as most of these disorders tend to be. Okay, so when you are chopping off carbons 2 at a time to make the acetyl-CoAs here and beta oxidation to digest your fatty acids up here, that's being done by an enzyme called acetyl-CoA dehydrogenase. So if your acetyl-CoA dehydrogenase is not working, I wrote a whole bunch of acronyms here and I don't remember what they stand for. Hold up. What does it stand for again? Medium chain MCAD deficiency, which stands for medium chain acetyl-CoA dehydrogenase deficiency. Okay, it's just the name of the enzyme. Medium chain. So it's you kind of end up with effects similar to the carnitine shuttle. Except this time the carnitine levels are completely normal, so that also builds up and causes problems too. Yeah. Liver issues. Enlargement of the liver, vomiting. Affects your appetite, dehydration, seizures, lethargy. Treat it. So this right here you can treat by just like supplementing more carnitine into the diet. This stuff, carnitine is a vitamin, I swear it was. Wait, which one? Carnitine is not a vitamin. I'm going crazy. What was I looking at again? I was looking at this. Okay, acetyl-CoA dehydrogenase. If you don't, apparently, as far as like fatty acid metabolism disorders goes, this one is the most common in North Europe and the United States. So let me... Most common FAOD in USA plus in Europe. So you end up with hypoketotic hypoglycemia. High acetylcarnitine. Liver and heart issues. Seizures. Treatment is... You try to get most of your energy from sugars and you avoid eating fats. And you also still have to take... Some people still have to take carnitine supplements. Okay. And then avoid fasting so that your body doesn't start going down the fat metabolism pathway too. Okay. So, treatment. High carb. Low fat. Avoid fasting. Yeah, avoid Then don't eat fatty acid rich foods either. Coconut oil it has here listed particularly. Okay, that's that. Over here, propionyl-CoA going to succinyl-CoA. Yes. So I skipped through a couple of things here. Actually, let me like... a couple of things were skipped there. So there's a few enzymes that might be knocked out over here. Either propionyl-CoA can build up. Make the blood kind of acidic. The other intermediate here. Anyway, these result in hyperglycemia and hypoglycemia, hyperammonia. Something about all this backing up causes like ammonia to build up. Trying to wrap my head around it. Okay. Acetyl-CoA. You end up with a lot of acetyl-CoA. Yeah. Oh well, okay. Well, we'll just call that good for there. 70%, and I get a passing grade. Keep reminding myself. 70%. Okay. I should move over here. There's a lot of, like, important things that I need to know over here. Okay, let me go look these up. They started doing the snapping and I thought it was gonna be like that one song from like Pokemon Colosseum. I guess that's not like an upbeat, calm, study to kind of song though. I had a friend describe the music in Pokemon Colosseum once as like emo jazz. I don't think all of it's like that though. It's more just like... It's just like, a lot of it's just like moody, I think. Okay, I was looking at this. Okay. just like look up. He's up first. Okay, so... Oh, is the music over? Well, it hasn't ended, it's just quiet for some reason right now. Maybe... I'll just let it play. Okay, so... If you cannot convert... phenylalanine to tyrosine, you end up with a disorder called phenylketonuria. Showing that to PKU, classic PKU. Okay, wait. There's two different kinds of PKU. So this is classic phenylketonuria. Symptoms, okay. So instead of going to tyrosine, phenylalanine instead gets turned into phenylpyruvate. Another case where when things aren't working in the body, it freaks out and starts making poisons instead. So that gets turned into two things. Phenylactate and phenylacetate. Okay. And these are no good. You don't want these to build up. They don't good. They don't good. They're no good. They cause... What do they cause? So the phenylactate and the phenylactate and phenylacetate gives your pee a musty smell? Whatever that means. Musty urine. You have a lot of phenylalanine in your blood, so hyperphenylalaninemia. There's lack of pigmentation since tyrosine... I'm gonna put this in purple, but tyrosine gets turned into melanin. Through yet another different pathway, so hypopigmentation because you're not making tyrosine. So you don't have any melanin. And then you also end up with developmental delay in seizures. Scary. Yeah, and you treat it with tyrosine supplements. Okay, so tyrosine supplements. You do that. So, yes, these. So that's classic PKU. The other kind of PKU is called malignant PKU. And so, malignant PKU, this enzyme right here is not working. So what does this do? So this leads to neurological deficits. There's seizures here too. So basically, this being knocked out here, like these two molecules right here, BH4 and BH2, affect like a whole bunch of other like amino acid pathways, and so if that's all knocked out, seems the brain just doesn't develop properly, and so babies with this tend to die within 2 years of life, which is very sad. So, yeah. Death. Yeah. It's not good outlook for a lot of these. Okay. The next one that I need to know is okay, if I go back to the urea cycle, there's there's an enzyme here, CPS1. There's a disorder here that is not directly linked to this enzyme, but there's a pathway on the side where we take glutamate. Oh, and our best friend, acetyl-CoA. Hey. And so you add those together, it turns into a molecule called NAG. And so NAG increases the activity of CPS1 there. Okay. Wait, plus arginine. Okay. I guess like arginine is also used over here. Maybe it's like a cofactor or something. Okay, arginine is also used over there. And so I should probably like actually look this up and see. There's like a period of time where I like fell behind in the lectures, and so there's some things here that I know better than others. This energy pathway here is something that I don't know so well. Oh, and acetylglutamate is NAG. And that is all that NAG does. Is one job. Okay. Yeah, I put my pen. Where's my pen? Okay, so this is also an autosomal recessive disorder. Okay. So the enzyme here is NAG synthase. And when you don't have NAG synthase, that's something I haven't looked at yet. No. What's that? Okay, wait. No, wait. There is... Oh wait, no, there it is, okay. So... hyperanemia type 1. So it affects the lungs. In fact, it usually shows up within, like, symptoms usually show up within the first week of life, so breathing is affected, feeding is affected. It's also one of those ones that doesn't have a very good outlook. If you don't do something about it, at least. So treat it by injecting carglumic acid. Which essentially acts as a replacement for NAG. Okay. So that's what that does. So... Okay, wait. Okay, so two types of high... So, ammonia here can build up in the blood, and there's two ways that that can happen. Number one is... There's... like... There's a... system of veins, like... It's called the hepatic portal down in your abdomen that like brings like blood like from like the regular circulation to like circulating around the liver, or like yeah, circulating like to the liver and like those organs. And so if you have liver damage from somehow from something like either like alcoholic like liver damage or like maybe like through like hepatitis infection or something like that, if your liver gets damaged somehow, it like affects the portal circulation, so blood isn't coming through the liver anymore, which means that ammonia isn't being brought to your liver. So if it's not being brought to the liver in the first place, you're not going through any of that at all. So that's called acquired hyperanemia. That's one way that happens. There's also congenital hyperammonemia. So usually if any of the enzymes here in the urea cycle aren't working, it's congenital hyperammonemia. Hyperammonemia. For so right here is the most common. So we'll call that 2-star. So for 2-star, it's X-linked. Recessive. And yeah. All others are oh wait, I should actually do Okay, I'll do 2. 1 right there. Okay, so this one will be 1, 2, 3. But where's the 5th one? 5 of these. Where's the 5th one? Enzymes in the urea cycle. The 5th one. Only list 4. Oh, wait. Actually, I don't know. They only list 4, so I'm not gonna worry too much about it. Okay, so... You end up with... isolated hyperammonemia, so the ammonium is high, but nothing else is out of the ordinary in terms of like blood levels of chemicals wise. Hyperammonemia. Lack of megaloblastic anemia. Blast. Anemia. There's a quiz session about this the other day at school. I did rather well on that quiz, but I can't say that anything like stuck in my head after I got out of there. Gosh, if I had like 1 more week to study for the test. If I had just 1 more week, 3 weeks instead of 2 weeks. I feel like that'd make a world of difference. Okay. Which one is this? Oh. Number 1 occurs in the... No, but you see it's an extra week, so then I have time to do the chores as well as study. I get everything done all at once again. Plus studying for my test in a nice and relaxed manner, not like cramming everything, like along with all my other... cramming for all of my other classes, like the week before the night before the test. Okay, so no, 1 also takes place. So 2, 5 over here. We'll just call it 5 since I already labeled these 1 through 4. 5 takes place over here. CPS is also not working for that one. So it's similar to the hyperammonemia type 1 then. Okay. But it's not called hyperammonemia type 1. Does it have a special name? I don't think it does. Hereditary orotic aciduria. What is that? Where is that? Mutation to uridine 5 monophosphate synthase, UMPS. Okay, no, that's also... No, that's part of the PRPP path. I'm in completely the wrong place. Why is it inside of the urea cycle lecture then? Strange. Strange. Enigmatic and strange. I have no idea what my professors are thinking. Anyway, it takes place down here. UMP synthase is... No, okay, wait. So these two are linked then. This... No. No, this is different. Okay, glutamate over here. Who's glutamine used again? I swear glutamine was used somewhere. Glutamine turns into glutarate, which turns into, that's not what I was thinking of. Here? Yeah. Yeah! Okay, no. No, that's also glutamate. I want glutamine. I need my lean mean glutamine machine. Where is it? Where did you go, glutamine? Anyway, okay. So we'll go back over here. How does this all connect together? PRPP can go to UMP. UMP? So... somehow over here we also go off and we make... So all of the different nucleotides, we make them all. So while we're doing that, before we do that, we need orotic acid. And to get orotic acid, we need carbamoyl phosphate. And to get carbamoyl phosphate, we use glutamine and CO2. So glutamine and carbon dioxide. Why did I erase that? CO2. Okay. Carbamoyl phosphate. We also use aspartate over here. Combine them. So Hereditary erotic aciduria comes in when this is not working. So Terry, the music has stopped. The music has stopped. Bring it back. Bring it back. What am I going to play next? That's the 3-hour Animal Crossing mix I was listening to before. All of these playlists are so short. Hmm. 4 hours of Animal Crossing music. Okay, yeah, I'll go with that. It's got rain sounds in the background. I could use some rain, honestly. It hasn't rained in the longest time over here. Okay. Okay. Back into the vibe, back into the vibe. Okay. Hereditary erotic aciduria. Erotic aciduria. So what does this one do? This one is also autosomal recessive. No hyperammonemia with this one, which I would assume it's not connected at all. Wait, how does this connect to the... Actually, why did they put this? Why did my professor put this in the Uriah Cycle lecture? How is this related? I'm not quite sure. Okay, anyway. I got stuff to be studying, so I'm not gonna worry too much about it. Anyway, the aciduria comes in over there. So... this one does lead to megaloblastic bulimia. I don't know if I like the rain sounds, actually. I don't think I like the rain sounds. Okay, wait. Is there one without rain sounds? Rooster Pomodoro. That's the one I was listening to before. Where is the Animal Crossing music without rain? This is 2 hours of city folk music. This one also has rain sounds. Wait. Does this one have rain sounds? Okay, this one doesn't have rain sounds. What's up with people and putting rain sounds over their Animal Crossing music? What if I don't want rain sounds? What if I just want Animal Crossing music? If they're gonna add rain sounds into the music, like, the least they could do would be to, like... add some reverb into the music, make it sound kind of like it's, like, playing in the distance. Don't just, like, straight up, like, put the rain sounds over the Animal Crossing music. People like rains, yeah. Well, I like rain sounds too, but, like, you could add a little bit more style, I think. A little bit more flavor to the rain sounds. I don't know. Maybe I'm just too picky about my rain sounds. Anyway, this sounds like it's exactly the same as the other playlist. What hour was this song? This is from, like... oh, this is from City Folk. 8 p.m. in the snow. I never played City Folk. But I swear I've heard this song in a different Animal Crossing game before, though. At least something similar to it. I don't know. I kind of fell out of it after, what was the one? After New Leaf, but like... No, that's a lie. I spent a lot of... No! I feel like I didn't spend as many hours on it because I actually finished like my catalogs in like New Leaf, Wild World, Population Growing. I haven't finished my New Horizons catalog yet. So I guess like, I don't know, still spend a lot of time. I don't know, it just gives me a different feel though, but like, I spent a long time with Animal Crossing, playing Animal Crossing. When I was a wee little bun. OTC, what is OTC? Oh. Wait. Does ornithine go to orotic acid somehow? Ornithine, there must be some sort of pathway to turn ornithine into orotic acid. I'm gonna make this portable. How turns into orotic acid, I guess. It's not really explained here. Okay. Okay. Okay, so that's why if there's too much orotic acid in the blood, there are two ways for that to happen. Amoyl phosphate. Is that? No, that's arginine. I don't know where the carbamoyl phosphate comes in. Okay. Anemia. You don't have hyperammonemia here. No. But this is also no hyperammonemia, isn't it? It is just... No. That one has hyperammonemia. Okay, hyperammonemia and no... megaloblastic anemia is urea cycle disorder. Anemia without anemia is orotic acid synthase disorder in the ribose, in the PRPP pathways. Yes. Okay, that's that. Oh, gout. I need to know about gout. Okay. Uric acid. So, xanthine oxidase. okay. Xanthine. Uric acid. It's down here. That's right, I did write that down. Okay. So there are 2 ways that you can get gout. 2 ways. So, way number 1, instead of knocking out the enzyme, this time the enzyme is like way too active. Way too enthusiastic. Xanthine, what's it called again? Xanthine oxidase. Either xanthine oxidase over here is way too excited about its job, and so it's saying, yeah, go, more. And it's making way too much uric acid, so it kind of builds up. That's option number 1. Option number 2 is you have kidney damage, like in the case of like diabetes or like any other kind of like injury or illness that will injure your kidneys, and so it's not, the kidneys don't filter things out like they should be, including uric acid, and so the uric acid builds up that way instead. So uric acid it doesn't dissolve in the blood. When it builds up and there's too much of it, it turns into crystals. So the reason why people with gout will have like really bad joint pain is because the uric acid will like build up inside of their joints and it will turn into uric acid crystals. And those crystals cause a lot of pain. So it does that. It will also it doesn't, even in like the case of like diabetes and like kidney damage, it doesn't not get filtered out by the kidneys. It still does, but it'll also like build up in the kidneys and cause like kidney stones, and so that's another source of pain. What else will it do? Inflammation, arthritis, yeah. Okay. So up and up. That's where gout comes from. Oh, yeah, I think, severe combined immunodeficiency. Purine salvage pathways. Okay. Adenosine to inosine. How did that happen? AMP deaminase. Okay. So, if you knock this out, you have something called severe combined immunodeficiency. So this causes the adenosine bases to accumulate, which affects the immune system, most in particular. lymphocytes. Cells, I believe. There's a couple different types, but like leukocytes is the one I was thinking of. This is also a type of white blood cell, so in particular, lymphocytes aren't multiplying and aren't working as they should. So that's what happens there. I get... Okay, yeah, I think... Maybe a cycle and Krebs cycle. I stretched. My shoulder popped very loudly. So arginosuccinate is important. Oh, because I already wrote it over here, but it can get turned into fumarate, which goes into the citric acid cycle. Oh, wait. So oxaloacetate becomes aspartate, which can shuttle it out of the mitochondria, but it can also turn, when it turns back into aspartate, it can also get shoved back into the nitrogen urea cycle over here. So that is how the urea cycle and the TCA cycle are linked. This feels like a conspiracy theory board. Every time I look at it, I'm just adding more to it. I haven't been writing down enzymes at all. Okay, wait. Synthase was what that was called. So it was just xanthine synthase or something like that, wasn't it? Look at the gout go. No, xanthine oxidase. Xanthine oxidase. Okay, so this is ADA, adenosine deaminase. I should write down the actual name. Adenosine deaminase. That's what goes on over there. Lignin PK. I probably need to know the name of that enzyme. Okay, wait. Where is... Oh, what's it? There's a lot that I still haven't looked at over here. Wait, no, I have looked at this. Okay, no, never mind. I did look at those. So... yeah, no PKU. Somewhere over here. Maple syrup urine disease. What the heck is that? Oh, alpha keto acid dehydrogenase. Where's that again? Okay, wait, alpha keto hydrate. Is that there or is it here? Oh, Oh wait, it might be somewhere over here. Where is it? Oh, okay, no, it is TCA cycle. It's right here. KG. I don't feel like writing out the whole name. Dehydrogenase. So anyway, if this is not working, you get maple syrup P. Maple syrup. Urine. Disease. Looks like maple syrup, and apparently it also smells sweet like maple syrup. Yeah. It's... similar in that you also end up with... yeah, developmental delays. Poor feeding. Also leads to seizures and coma. Okay. And you treat it with dietary adjustments. Okay. Oh! I never went back into the glycogen storage disorders. I just realized. I need to know those. These ones are... I think you treat both of them by just like... this is all the way at the bottom there. But... yeah. Hold up. There. Okay, no, here they are. So glucose, 6-phosphate gets turned back into glucose. Gluconeogenesis pathway by an enzyme called lurk 6 phosphatase. And so if you knock that out, that's called... this one's got a fancy name. It's called von Gierke's. It's spelled like this. Von Gierke's disease. If you can't... I don't think it's glycogen phosphorylase that's affected. But... it might be glycogen phosphorylase, actually. Anyway, if you can't debranch your glycogen, you get something else called Cory's disease. So Cory's disease ends up with similar symptoms to von Gierke's disease. Von Gierke's disease. Lactic. Gierke's? Gierke's? Is that how you... Hold on. Von Gierke disease. Google, tell me how to say names. Okay, wait. Does Wikipedia have sound clip? No it doesn't. How do I say this? How do I say this? How do I say this? Okay, wait. It's a YouTube video with 0 views. Okay, hold on. I'm turning the music down so that we can hear this. How do I pronounce this?
Von Gierke's disease.
Gierke's?
Von Gierke's disease.
Gierke's? Gierke's? Googlers? Geekers? Here's a different video with a I think this one might be better. Okay, wait. Pronunciation intro. I just want to... They got like a whole explanation on... I just want to hear the word. I don't need like an explanation on how it's pronounced. Case study... howtopronounce.com? Merriam-Webster. Always has sound bites. Okay, wait.
Von Gierke disease.
Von Gierke. Oh, okay. Gierke. It's Gierke. Ooh, yeah. I think I'm not gonna take a break right now too. I might just like finish up going through the things that I'm going through right now and then like maybe setting you guys free. And then I'll finish up the rest of my studying before I take a little bit of sleep for the night. It's nice that I don't have anything going on for the rest of the day. There are other things for the rest of the day, but I don't have to be at school for them, so I can just like go home and sleep after the test. I also don't have anything going on Tuesday, so like I can catch up then. I was thinking about streaming Tuesday, but like streaming a video game Tuesday, but like now that I think about it, I really should spend the day. If I'm gonna go home and I'm just gonna sleep after the test, it would be prudent of me to catch up on Tuesday. But we'll see how much energy I have. Maybe I'll have a lot of energy, and maybe like I'll get all of my studying done like Monday afternoon like I should be doing, and maybe I'll have time to do other things on Tuesday. I don't know. I feel like if I don't go scheduling streams for myself like days in advance and like telling myself I will stream, I'm going to stream, and then like actually taking the commitment to like schedule the stream, I end up not streaming. I feel like there have been multiple instances where I've said, yeah, I'll have time to stream then. I'll be able to stream then. I'm gonna think about streaming then. I'll choose a game and I'll stream then. But then I don't schedule a stream, so I just end up not streaming. So I feel like if I really want to stream on Tuesday, I would have to commit now and schedule the stream. I don't know. I got a phone call I have to make tomorrow too. I'm not looking forward to it. I gotta call my insurance because they're being weird. Anyway, I just have a couple things going on tomorrow. I'll get through it. I made myself a promise. I made myself a promise that if tomorrow goes well, I'm going to get myself a little treat. And so that's also motivating me to try my best. I want to. I was looking on Mercari the other day and I found like a little pouch with my Oshi's face on it that I don't have in my collection yet. It's on my wish list. I don't have it in my collection yet. I'm gonna get myself if tomorrow goes well, I'm getting myself that little treat. I deserve it. I deserve it. I found like a meme like a while back of like, it was like a meme image. It's like of some classical painting of like a very big baby with a very smug face, and it's like the baby it's not like really a baby, it's like a baby with a man's head. It is absolutely meant to represent something, but like it is a baby with a man's head, and the man baby is licking a lollipop, and the lollipop is being held up by like many littler men, and so it's captioned so that like the lollipop is like a little treat, and the baby man is captioned me, and then all the little people are captioned my limited funds. And I think about that meme a lot. I think about it a lot, especially when I'm getting into little treat kind of moods. I remind myself, I can't be doing this to my limited funds. But I haven't been treating myself in a while. I don't know, everything that I've been buying recently has just been like necessities. Just like groceries and bills and things like that. So I think it's fine if I get myself a little treat after the exam. I think it's okay. You see? I have to get something nice every now and then. Anyway, what does this do? Lactic acidosis. Okay. Hypoglycemia. Lid for enlargement. Hepatomegaly is enlargement of the liver, and you also get seizures. The treatment is frequent feeding. So, oh, that's right, because this is going back to glucose after you make... Yeah, after you do glycogenolysis, you go up the gluconeogenesis pathway to make more glucose. Okay. Okay. So yeah, I treat that with frequent feeding. Okay, and then Cory's disease is basically more or less... You'll get the same out of it that you get at Van... What was it again? I don't remember. It wasn't Jerky's disease. Gurkha? It was like Gurkha or something like that, right? On Gurkha. Okay, Gurkha, Cory. Okay. Well, in Gurkha's, I would assume it would be less severe than Cory's disease, though, because on Gurkha's, you can at least, like, You can at least like break down the glycogen and have it go down the glycolysis pathway here. No, Gurkhas must be less severe than Cories, sorry. I think I got that mixed up. But anyway, Cories, you can't unbranch your glycogen. So it just builds up. And it's bad. And you can't use it for anything. So it's bad. But Von Gurkhas, at least, you can't go back up here, but you can still go back down here. What do my professors have to say about this? Massive enlargement of the liver in Van Gurkhas. Pompeii? There's a lot here. Okay, wait, what's Pompeii? Pompeii disease. 1,4-glucosidase. What is that? Glucosidase. Where is this one? Oh, wait. This is completely unrelated to what I'm doing right now, but I also need poisons that will affect the electron transport train. I guess it's also related because it's also kind of like disease state, but I remember the acronym. I don't remember like what they're named though. It was like DR, it's like Draco with like 2 A's and 2 C's. This one is like azide. This one is cyanide. This one is carbon monoxide. I think this one is like ornithine or something like that. Okay, maybe I remember them a little bit better than I... Malvoy. Poisonous, poisonous. He'll poison your mitochondria. He'll poison your mitochondria. Did you see? Do you like my thumbnail, by the way? I haven't mentioned it for the entire, like, how long have I been streaming now? Like 5-6 hours? I haven't mentioned it at all, but like... maybe I should draw it, not over there. Anyway. Yeah, it's more like... yeah, that's better. Mitochondria has little... actually, this is like a textbook mitochondria right here. It's kind of not actually like this. They kind of like aggregate together and they actually form like big membranes instead. It's a little bit freaky. Anyway. That's your fun biology fact of the day. They don't actually, mitochondria don't actually look like little jelly beans like this. They're a little bit bigger and a little bit freakier. So this is mitochondria. Ah! Okay, I almost closed the file. And I've been poisoned. By Draco. How do you spell his name? I think it's like Malfoy. Draco Malfoy. Poisoned by Draco Malfoy. Okay. This one has some sort of weird, like, complicated sciencey name. It's like D... something something tall. I don't remember what it was. I need to look it up. This one was like... retinoin? Or something like that? Yeah, somebody fell asleep. But that's fine, that's fine. I'm flattered that you guys would want me to have my voice on in the background and that you'd want to listen to me crash out about metabolism while you sleep. Oh. I'm flattered that you find my crazy person ramblings to be relaxing and lulling. Lullaby-like. I completely don't remember what this one is at all. It's like... It either ends in like an... I think it ends in "een" also. I can't say I know what it is though. Let me... Gosh, oh, I don't know. I don't know. Where is it? There is a diagram somewhere. There's a diagram here. Okay, no. Retinoin. No, it's rotenone. I was close. It's... rotenone. 2,4-dinitrophenol. I was not right. I was right in that it ended with an "ol." Okay, so 2,4-dinitrophenol. Okay. This one I was not right at all. It's called antimycin. Okay. Those are your electron transport chain poisons. You see, I like acronyms, but the problem with like little acronyms and mnemonics is like, I need to remember what the things that they stand for are. I remember Draco. I don't remember what Draco stood for. What do you stand for, Draco? Tell me what you believe in, Draco. There's another one. There's like cofactors for something. What was it again? Cofactors for one of these enzymes, I think. I think it might have been pyruvate dehydrogenase. But it's like, I remember the acronym. I don't remember I remember it's not an acronym, it's a mnemonic. I remember the mnemonic, I don't remember what it stands for. It was like the lovely little enzymes for nerds. Let me like look up what it was again. I was just like, I remember it because I was like listening to my professor's lecture and he said the acronym and I was just thinking in my head, that's a really bad acronym. But I don't know, sometimes it's like I feel like it's the bad ones that stick out and like stick with you most. Sometimes you just like look at something and it's just like, that's not clever at all. And precisely for that reason, it just sticks in your head and it doesn't leave. Where was this again? I think... I think it was... It was pyruvate dehydrogenase. I was right! I was right! The cofactors for pyruvate dehydrogenase are the lovely little coenzymes. There's no little, it's just the lovely coenzymes for nerds. Okay, the lovely no, okay. It's NADH, it's FADH. I don't remember the rest of them. So, NADH, FADH, TPP, coenzyme A. That one's easy enough. And then the L is lipoic acid. Okay. Cool. Awesome. That's that. What was I doing before this again? I got sidetracked. I think I was just thinking about Von Gurkas again, so I can leave that for now. What else did I need to do? I haven't gone over vitamins yet. Haven't gone over vitamins. I was distracted by Draco. Over here. Okay, wait. 2,4-dinitrophenol, rotenone, antimycin, azide, cyanide, carbon monoxide, ornithine. It is ornithine, right? I didn't double check that one. I was completely wrong, so legomycin. Okay. Away with ye. You're completely wrong. Ooh. So mycins. My Sims is evil. Do you know that game? My Sims. I kind of like My Sims actually. It was a nice, cute game. I played like the DS version of My Sims when I was a kid. There wasn't much to do in it. But it was cute. It was nice. Poisoned by Draco Malfoy. My Sims. Mycins. Oligomycin and antimycin. Poisonous. My Sims is like different from like regular Sims. It's like it's not Sims is like Sims, but My Sims is like if you took like it's not even Sims. Like the gameplay is just like not remotely Sims whatsoever. It's basically like the one I played at least was basically like it's like it was like a save the town type RPG. It was like cute little characters. It was yeah, and like you could dress up yourself. There's a town that you could talk to. I don't know. I guess it was like mildly Animal Crossing like because you also had like a house that you could decorate. I think there was like more things to do and like there was more things to do and like I think it actually was a little bit more Sims like if you were to play like the Wii version or like the other like other console versions of like My Sims, but like the DS version was just like very small. It was just like I don't know. Was it like I guess it's like kind of like Harvest Moon without the farming. There are like mini games to do. Yeah. I don't know, basically the big thing was like collecting clothes and like dressing up and like collecting furniture and like decorating your house and like walking around and like doing like quests and like helping the villagers and like unlocking new areas to explore and stuff like that. Except it was like a DS game, so it wasn't that big. And then they made like spin-offs too. There's like a spy themed one where you like it was like story mode Sims. It's like make the Sims cute and like make it story mode. So anyway, yeah, there was like a spies themed one. There's like My Sims Kingdom. Which I think My Sims Kingdom was like more like in line with like the console like large console like Wii kinda, Xbox kinda, My Sims games. I don't know. It was charming the way, as far as I remember, it was charming. I liked My Sims. It was cute. It was charming. It had a nice charming cast. I remember like the curio shop that you get like some of like the more unique furniture items from was like run by like this. It was run by like this goth girl character. She was like, it was like. When I say goth girl character, I mean like. Kind of like Gotholita style. She was like, how was she again? I think she was like she had like bangs or something like that, and it was like bun, and it was like bags under her eyes. It was like, I think it was like, yeah, and then she had like the I forgot what exactly, but it was like then the Mary Janes. She had the fit going on, you know? She had the fit going on. It was like the corset thing and like ribbons and stuff. Something like that. Anyway, she had the look, she had the fit. It was cute. I'm gonna leave her there, actually. My Sims Curio Shop owner. From memory. You remember the Eurocamp girl? She does look kind of like Eurocamp girl, doesn't she? She does look like Shimarin when I draw her like that. Okay, wait, what does she actually look like? Maybe I will take a break. Okay. Shimarin. Not Shimarin. I want the Curio Shop girl from My Sims. Okay, wait. What if I just look at My Sims? There's probably some sort of My Sims fan wiki somewhere out there. My Sims is on Steam? Oh. Wait, no, it's probably like the Wii version of My Sims though. Wait. Oh, bundle My Sims and My Sims Kingdom together. I can't just buy them separately? I have to buy My Sims and My Sims Kingdom together? Yeah, I don't remember. Why are there dinosaurs? I don't remember any of this. This must have been Wii stuff. This isn't the My Sims that I remember. This isn't my Sims. That's not my Sims. Okay, wait, where's the Curio Shop girl? Where's the Curio Shop girl? I don't want the Sims Curio Shop. I want My Sims Curio Shop, please. My Sims. Margaret. That's from My Sims Kingdom. I need My Sims characters. Okay, wait. DS characters. My Sims. Ashley. I remember Ashley. Charlie. I remember Charlie. Elizabeth. I remember Elizabeth. Emma. I remember all of these characters. It's like something's being dug up from the deep recesses of my mind. Okay, wait. Here she is. Olivia. Okay, here's what she looks like. Okay, wait. So it's more like... Here, wait. Oh, good night, Daniel. Have a good night. Thanks for sticking around for so long. Okay. Okay, so it's less like that. It's more like... Here, this will be my break. I'll take quick break with this, and then I'll look over everything one more time, and then... It's getting late, and I've been streaming for a really long time. Okay, Olivia My Sims. Put her over here. She's like... It's more like, okay, so she's like... So actual. Olivia My Sims. She's got like that whole hair covering one eye deal going on. And it's like... I guess it's just like... one strand like there. I'm taking artistic liberties. That goes like that. The bun is like more in the back. I'm just gonna draw it like right over there. And then... She's still got like... collar over here. She's got like a bow over here. It's like that goes like that. There's buttons on her shirt. She's wearing an apron. Frilly apron. Cute apron. That goes like that. She's got like kind of like pleated skirt underneath the apron too. So that goes like that. She's still got the Mary Jane going on. And then that kind of goes like not all the way down. It's like quarter sleeves. Yeah, like that's okay. And then still like that. More like that. Close enough. Maybe I will give her Yudukan buns. Here, we'll put that over there anyway. Like that. Okay. That's that. What was I doing? I was looking at critical poisons. Maybe I should spend a little bit of time going over the vitamins, at least. Okay. I'm not gonna write it down, I don't think, because I don't really have room to write a whole lot more down, so I'll just leave that up there. I'll let y'all admire that. Admire my handiwork. So, yes, I will leave that up. Right there. And I'm just gonna talk about the vitamins. So... Vitamins overall can be separated into two groups. There are water-soluble vitamins and there are fat-soluble vitamins. So fat-soluble vitamins are... they kind of behave like hormones and like signaling molecules. Like they go around the body and they do things like very directly. So I don't really need to know a whole lot about them for my tests. I think the big one that I need to know about is vitamin A, which includes retinol and beta carotene. So... Vitamin A. I think vitamin A toxicity is rare, but it is possible to eat too much vitamin A. But again, it's really rare. Vitamin A deficiency. You can also be vitamin A deficient. So vitamin A is important in cellular growth, vision particularly, and also immune function. Oh, yes, and so it's rare to have vitamin A deficiencies, but the big things about vitamin A is if you don't have enough vitamin A, it affects your eyes, and so night blindness is often an early sign of vitamin A deficiency. You also end up with like skin. Yeah. Well, not like skin, but like you can end up with dry eyes. Blindness, in early onset blindness in children is like very preventable. Yeah, I think like, what was it? Like vitamin A deficiency is like something about, what was it? What's the wording here? Wait. No, okay, yeah, vitamin A deficiency is the leading cause of preventable blindness in children. That was the factoid I wanted to state. Okay, so yes, so vitamin A, your eyes and your immune system. If you don't have enough vitamin A, you start going blind, or at least you can't see at night, and what was the other one again? Oh, dry eyes, that's right. So that's the only lipid-soluble vitamin I need to know. Water-soluble vitamins are B vitamins and not V vitamins. What else? So the not B vitamins is vitamin C. It's just vitamin C. So moving on to B vitamins, there's a couple different classes of B vitamins. So there is the water-soluble vitamins also they usually act as like cofactors for like other processes. So you use them along like other enzymes and stuff to help like, yeah, to move enzymes forward and get reactions moving. So there's the energy-releasing B vitamins, which would be vitamin B1, 2, 3, 5, and 7. There is the hematopoietic vitamins, important in red blood cell formation, which is vitamin B9 and 12, and then the rest of the V vitamins, which is vitamin B6. I need to know the actual names of all the vitamins too. Okay. Okay, so vitamin niacin is B3. Thiamine is B1. Yes. Riboflavin is B2. Biotin is B7. And pantothenic? Thenic? I'm gonna say thenic. Pantothenic acid is B5. Okay. I gotta think of some sort of mnemonic for these. Okay, wait. Thiamine, riboflavin, niacin. I know niacin. Thiamine is 1. Riboflavin is 2. Folic acid 9. Cobalamin is 12. Pyroxidine, pyroxidol, and pyridoxamine are all B6 related. Okay, so it's like, if it starts with pyrid, it is a B12 vitamin. folic acid, cobalamin are for blood. Folic acid, cobalamin. Folic acid, cobalamin. I don't want to study anymore. But I need to go over everything before the test. You're trying to draw me from an angle, but you don't think it looks good? Draw it anyway. Again and again. Again and again until you're satisfied with it. No, listen, listen. Listen to me when I say you have to be bad at anything. You have to be bad at something before you become good at it. You have to you have to not know something before you know it. You have to sit around for 5 hours feeling stupid and struggling to remember the names of vitamins before they stick into your head and you know them and you ace your test. You get a 99.8%, all above the rest of the class. It's a cliche, but you really do. Just keep practicing and you'll get better and better. Even if you don't feel like you're getting better, you get better and better and better and better. And eventually it's gonna be 10 years later and you're gonna look at the art that you made 10 years ago and you're gonna be like, oh my goodness. Good gracious. It's so different. It's so different. I draw so much better now. And it's it really doesn't feel like you're improving, in the moment. But trust me, I need you to trust me when I say that you are going to look back one of these days and you're going to see the things that you were doing in the past compared to the things that you do in the present. And you're going to say, yeah, I've learned a little bit. I have gotten better. I have improved. Just if I have advice for art, it really is just focus on getting your fundamentals down, but also focus on finding things that make art fun. If you have those, focus on finding things that you like drawing too. If you're have something that you like drawing, that also makes drawing more fun to do. Just just keep going, just keep going. Find reasons to enjoy art. Find things that you want to try out with your art too. I think that's also a good thing to help push you forward. Look at the way other people draw and try to pick it apart. Try to be what do you like about a drawing? Is it the shapes? Is it the colors? Is it the way that the lines are done? Think about that and compare it between different artists. Compare it between different artists and see what's similar between the art things that you like and experiment. And see what's fun to you to draw. Yeah. You drawing because I'm your ocean? Wow! Wow! Shucks! Well, shucks! Honestly, I think that's also a reason why I kind of wanted to start streaming too. Right before I decided to start streaming, when I was watching that Suisse concert towards the beginning of the year, I think it was kind of just that impulsive in the moment thing, that desire for self-improvement, but also just I don't know, it's just the kind of thought that it would be cool. It'd be cool and groovy and shagadelic and all that kind of stuff to like the idea of like inspiring something in the way that my Oshi's inspired me. Oh no, 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 no. It's nice. It's a nice feeling knowing that. Seeing that I've managed to do that already. Already. A mere half year into being a VTuber. VTuber. Yeah, yeah. It's cool, it's cool. I'm gonna keep going. I'm gonna keep going and keep trying to improve my art skills and keep trying to improve my streaming skills as well. Just you wait, just you wait. One of these days I'm gonna go and I'm gonna turn back however many years from now. I'm gonna look at the stuff that I'm doing then and I'm gonna compare it to what I'm doing right now. And I'm gonna say, yeah, I've improved a lot. And another thing too, I think like when you improve, like I tend to look back at the stuff that I was doing like in the past too, and I think like there's a tendency to be more harsh on yourself like when you're actually doing something as well. Like when I look back at like the art that I made in middle school now, it's just like there's a point where I was like just like completely dissatisfied with it, and like I was just like, completely like, oh, I gotta keep improving, and like this is not good at all, this is not what I want to be drawing. But like I look at it now and it's just like there's something in there. It's kind of cute, it's kind of nice actually. I kind of like this, and like I can kind of see like the kind of like things I can already pick out, like the portions of my art that I focus on now, like the traits of my art that ended up being important to me that I wanted to work on now. Like I can see it in like the art that I was making all the way way back then when I started drawing seriously in like in 6th grade and middle school. So I will say, you're probably doing a lot better than you think you are. You're probably doing a lot better than you think you are, and you will look back at your art one of these days and you might also think to yourself, hey, it's kind of cute actually, it's not that bad. It's not too bad. Yeah. You wanna like know something else that I was doing like a lot when I was younger and I was trying to improve? I would like watch like a lot of speed paints. I would watch people draw and I would like try to like pick apart their techniques. So yeah. I don't know, the other stream I mentioned like there's like a lot of like I try to avoid like YouTube art tutorials that are like, this is bad, don't do this, this is bad, and this makes your art bad, because I don't really believe in that. I don't really believe like there are things that you can do to make art bad. Like there are things that you should avoid if you're like going for a particular feel or a particular look, I will admit that, but like I don't think there's such a thing as bad art. But anyway, I recommend like there are like painters on YouTube that will just like go over fundamentals, like purely from the perspective of like going over fundamentals. There's like I mentioned like Saito Naoki and like his channel the other day on stream, and it's like it's good because like the vocabulary that he uses is like it's less like this is bad, this is good, and it's more like this gives this sort of feel, but if you're going for this sort of feel, you should try this instead. And I appreciate that wording, so yeah. And it's helpful too because like you can like sort of like pick out maybe the things that you might do in your own art and like the pieces of the art that get sent to him. And so see like the changes that he makes and be like, okay, so maybe it's just a little bit more like this. Okay. I found out about him because like Hosho Marine, you know, Hololive VTuber Hosho Marine, she sent in like a piece of like Kali that she drew for him to like paint over and like give his critiques on. So that's how I started watching him. But yeah, I appreciate the way he like words his advice. It's like I feel like he's very careful not to like put down um the budding artist that turned to him for advice. So it's good. It's good. But yeah. Just expose yourself to art, I think. All sorts of art, really. Not just like anime art, but like I think like a lot of like the direction I started going into right now is because I started like more looking at more looking at like more like impressionist art and more like ew. There was a fly on my computer. Not a big one, just like a little like fruit gnat. They get in sometime. It might have been a mosquito actually. Maybe I should have. Maybe I shouldn't have just like blown it away. Maybe I should have given that guy a good slap. Anyway. Expose yourself to all different kinds of art. You might surprise yourself. You might find something that you like in the shapes and the colors. You might surprise yourself. But yeah. Not marine, not marine. What do you mean not marine? When you look past like certain things, she's a good artist. She's like, I don't know. I really love like the efforts that she does, how much effort she puts in her MVs, and like I think she said in the past before, like when she makes MVs, she always comes out in the red. Like legitimately, she always comes out in the red. It's just like she puts so much effort into like fostering creativity, I feel like. You can really feel like she has a lot of love for like what she does, and she has a lot of love for her community and like the VTuber communities and like otaku communities as a whole. Like what she does, it just really comes from a place of love. A true understanding of what makes, of like what her audience likes and what they're coming to her for. She just gets it because she's coming from a similar place, I feel like, and so she's like. Success based on like years and years and years upon years of experience. But anyway, yes. Back to art. Back to art. Those are my thoughts. But yeah, just like experiment. Be kind to yourself. Give yourself some grace. And like just keep like looking at things that you can improve. It's not always going to feel like you're improving, and it's going to be frustrating at times, but you know, that's where the giving yourself grace comes in. So yeah, it's a continual process. Improvement in art is definitely a very long game to be playing, but you do progress in it. You definitely progress in it. I progressed in it, and I wasn't doing anything in particular to improve. I was just like kind of drawing. Oh, I want to draw anime girls. I want to draw my Oshi. I didn't even know the word Oshi back then. I was just like drawing him obsessively over and over and over again. Oh, yeah. The improvement will come whether you change and improvement will come whether you want it to or not. And like once you like know what you're doing too, like it gets easier like to adjust and like experiment things and like say, okay, I'm gonna keep doing this, I'm gonna stop doing that. Yes. Yes. Yeah, anyway. Am I done with this? I think I am done with this. I was telling you guys about vitamins, that's right. Okay, wait. Cover that part up with my hand. B1 is thiamine, B2 riboflavin, B3 is niacin, B5 is pantothenic acid, B7 is... I'm not cheating. Biotin. Okay, B9 is folate, B12, it's... what was it? It's got the name of... it's got some sort of metal in it. It's... the C. Like get out. It's getting late. I've been streaming for so long. Cobalt. That's right. Okay, wait, I'll just run through these real quick. Okay, B2, riboflavin. You use it in energy metabolism. It's used particularly in oxidoreductase reactions. I don't really think you can overdose on B vitamins. It's like, you don't store them. And your kidneys, like, whatever is like extra, it's just like gets filtered out in the kidneys and you pee it out. Vitamin A, you can remember dude is scary? It's not that scary. It's just eat your carrots. Eat your carrots, eat your orange and yellow vegetables and fruits, and you'll get plenty of vitamin A and you'll be fine. Eat your fruits and vegetables. As long as you're eating your fruits and vegetables, you have nothing to worry about. If you're not eating your fruits and vegetables, take a vitamin. Take a multivitamin, and then you have nothing to worry about. Anyway. I don't think you can't really overdose on B vitamins, I don't think. It's vitamin C too, you can't really overdose on it. Anyway. If you're vitamin B2 deficient, it's not really dangerous. It's not really comfortable either. You get a whole lot of like stomach symptoms. Stomatitis, chylosis. Oh, your lips get all scaly. Your skin gets all scaly. Your skin gets all weird and scaly. And so do your lips. So does your tongue. So that's what happens if you don't have enough vitamin B2. Pantothenic acid, that was B5. Right? Yeah. So smart. Pantothenic acid, is a precursor to coenzyme A. Okay. It's not toxic. So... B5, you need B5 to make CoA, which you need for acetyl-CoA, our friend. You see him over there? Many places on the board over there. Donzi, good morning. I hope you had a nice nap. I am going through the vitamins and then I need to get sleep because it's like almost 3 in the morning and my test is at 8 a.m. But yes, I'm just going through vitamins really quick. So pantothenic acid, vitamin B5, you need it, you use it to make coenzyme A. Biotin, that was vitamin B7. Biotin, you get it from like almost everything. Okay. Especially egg yolks, yeast, and nuts. Nice. So it's a coenzyme for carboxylases. You have a lot of bacteria that just kind of live naturally in your gut. It's like a symbiotic kind of relationship that you got going on between the two of you. The bacteria in your gut, you feed them every day and they love you and they make you things. One of those things that they make you is biotin. They say, thank you for feeding me. Here's lots of biotin. Mwah, mwah, say the bacteria in your gut. Mwah, lots of biotin for you. So, that's something that they do. They help you digest things as well, but like, yeah. They do lots of things. The natural flora of the gut. Biotin deficiencies are also rare. They'll happen with long-term antibiotic use. So, you know, antibiotics aren't specific. If you have like an infection that you've been taking antibiotics for a long time, it'll kill off like the things that it's supposed to kill off. It also kills off all the bacteria in your gut, so it's not that good. But like, you know, you kind of need it, so it's also good. It's just side effects. So, that happens. Consuming raw eggs apparently can give you biotin deficiency. How does that work? Avidin. Hold on. I'm curious. Avidin. Oh. Oh, I see. There is a protein in raw eggs called avidin, and the avidin will trap the biotin before you're able to use it, essentially. In short, the simplified version of that. Okay, so if you're deficient in biotin B7, it's either because you've been taking antibiotics for a really long time, so that's wiped out all the bacteria in your gut, and they can't make you biotin anymore because they're gone. They're dead. You need to replace them. You need to take some probiotics and get some more. It's because you've eaten raw eggs, lots of raw eggs, and so you've also eaten lots of avidin, which is taking up all of your biotin before you can use it. Or parenteral nutrition without biotin. What does that mean? It's just like you're not getting enough biotin in your diet? It says unlikely, so that's probably it. Yeah, option number 3 is you're not getting enough biotin in your diet, but like biotin is like literally everywhere, so it's like almost impossible not to get enough biotin in your diet. So that is that. Thiamine, vitamin B1 is used. It's used in transketolases as a cofactor for transketolases. Oh, it's one of the TPP! It's the TPP! The lovely coenzymes for nerds, the TPP! In pyruvate dehydrogenase, that's thiamine. Okay. Vitamin B1. So thiamine B1 is TPP. You get it from grains, wheat germ, yeast, and dairy. You can become deficient in vitamin B1. So B1 deficiency is called beriberi. So beriberi is common in places where they don't eat a whole lot of whole grains and what was it again? Whole grains and dairy. If you're going through a rough patch in life and you find yourself eating nothing but white rice, you might develop beriberi. Chronic alcohol use can also cause, long-term alcohol use can also cause beriberi, B1, vitamin deficiency. And then, yeah, malabsorption syndromes, dietary related deficiencies can also cause beriberi. Okay. So beriberi comes in 2 types. You have wet beriberi and you have dry beriberi. So wet beriberi comes from effects on the cardiovascular system. You hold on to fluids. It causes like swelling, congestive heart failure. Dry beriberi affects the nervous system and it causes like sensation of like burning limbs, burning feet. Okay, so wet and dry beriberi, thiamine deficiency, TPP, thiamine B1. Remember that. Niacin. Niacin is used in redox reactions, so think when you're adding electrons onto things, like you're turning NAD into NADH, or you're turning NADP into NADPH, or you're turning FAD into FADH. You're reducing it's called reducing, but you like add on. You add on an electron. Yeah. Reduced is gained. You add on the electron. So yes, niacin is used in reduction reactions, redox reactions, reduction oxidation reactions. You get it from nuts, legumes, grains, pork, beef, fish. Some flours and like cereal products will be fortified with niacin B3. And then high protein foods rich in tryptophan will also give you some niacin. Okay. B3, niacin. Comes from a lot of stuff. It basically comes from everything. Vitamin B3 deficiency is a condition also called pellagra, which is similar to, what was it, pantothenic acid? Wasn't it deficiency? No, riboflavin deficiency, B2. B1 and B2 deficiency are a little bit similar, but B2, B3 deficiency are a little bit similar. B3 pellagra, is... it starts out as like... lung inflammation, but like as it progresses, it turns into... there are 3 Ds that it turns into like as you move back into pellagra. Or move from just like mild deficiency into pellagra, so... there is sun-sensitive dermatitis, diarrhea, and dementia. Those are the 3 Ds of pellagra. Get your niacin in, guys. So again, like... chronic alcohol use, like... tricks your body into thinking that it's in a fed state, and so... yeah. You're like storing like... your body like moves towards like storing energy in the form of like fat and glycogen, but like you're not actually like getting any nutrients in. So like you end up like malnourished. So like alcoholism, like anorexia, AIDS, and then cancer chemotherapy, it also has as that really at-risk group with pellagra here. Ooh. There's like a picture in the slides, in the lecture slides here, of somebody with pellagra, and it's like really bad. I don't think I'm gonna describe it. Okay. So yes. Get your vitamin B3 in. Okay. It's generally reversible until you reach the 3rd D, dementia. At that point, you're pretty much done for. But it takes a while to get to that point. As long as you're eating right. It's in a lot of stuff. Niacin is like in almost everything, so as long as you're eating right, you should be able to get enough into your diet. Vitamin B6, pyroxidine, is... also a cofactor for many things. It's used by glycogen phosphorylase. It's also used in heme synthesis for your red blood cells. It's also used for neurotransmitters. Deficiency is also very rare. You get it from fish, organ meats, potatoes, starchy vegetables. You know, it's also like fortified, or it's also found in like fortified like cereals and meats. Sorry, cereals and like also in fruits. A lot of like the foods that we eat like these days, like processed foods will be like fortified with vitamins and minerals. So it's like, if you're eating like any kind of like modern food, you generally don't have to worry about vitamin deficiencies as long as you're eating enough. Hmm. Hmm. So that is B6, pyroxidine. Pyroxidine is counted under the other B vitamins. I remember now. Pyrrod means it's miscellaneous. Folate and cobalamin were related to red blood cell genesis, and then all the other ones are just purely energy related. Anyway, cobalamin, vitamin B12. We use it in beta oxidation, so the metabolism of fatty acids. It's also used in methionine synthesis and breakdown. Okay. Only bacteria can make vitamin B12. You cannot make it yourself, but the friends in your gut can. So the friends in your gut can make it. The friends in other animals' guts can also make it, so you tend to you can get it from meat, eggs, dairy products, fish, poultry, seafood. If you're vegetarian or vegan, you need to take a supplement for it. Yeah. B12. Oh, folic acid is B12. That's right. That's right. I remember because I used to. Not like the lab job, but a different clinic job. They would always recommend that the pregnant ladies coming through the clinic take folic acid, and so that's why. Okay. If you're taking certain medications, like if you're taking metformin for diabetes or you're taking proton pump inhibitors, you have some acid reflux. You might also need some folic acid supplementation. Yeah. Oh, this is also where the anemia comes in. The megaloblastic anemia comes into play again. Megaloblastic anemia had to do with. It wasn't orotic acid, was it? It was. It might have been. No, it was one of the hyperammonias. It was congenital hyperammonia. So congenital hyperammonia can result in megaloblastic anemia, but vitamin B12 deficiency can also result in megaloblastic anemia. If you end up with megaloblastic anemia and you're taking folate supplements and vitamin B12 supplements. No, that's the same thing. Wait. No, wait. Vitamin B12. B9 is folate, B12 is cobalamin, okay. I'm getting all turned around. Okay, vitamin B12 is cobalamin, okay. So, if there's a pathway between the two, they have to be taken together. But anyway, if you're taking cobalamin and folate supplements and you still have megaloblastic anemia, it probably means that okay, no, never mind. I don't know what I'm trying to make sense of my thoughts over here. Anyway, megaloblastic anemia can be associated with either cobalamin deficiency or with congenital hyperammonemia. So if you're taking cobalamin and folate supplements, and your anemia is not improving, that means that you probably don't have a deficiency. It's probably instead an autoimmune disorder called pernicious anemia. And so pernicious anemia is a condition where the immune system attacks the parietal cells lining the gut. And so the parietal cells make a few different things. One of the things they make is a substance called intrinsic factor. And so you need the intrinsic factor to absorb vitamin B12. So if you have no parietal cells and you have no intrinsic factor, that means the vitamin B12 just runs straight through you and you're not taking any up. And so you end up with that condition. It's good. Not good. But good that I'm learning it good. So that is that. Folate. So you need to take vitamin B12 and folate together because vitamin B12, B6, and riboflavin was like what, B2? Riboflavin. It was B2. I was right the first time. Anyway, a whole bunch of vitamins like are used as cofactors to turn B9 into B9 folate into, it was B9, right? It was. Yeah, I'm learning, you see. B9 folate into a usable form. Anyway, if you're deficient in B12, then it's not good. So that is that. Deficiency. You become deficient if you've been using a lot of NSAIDs, so like aspirin, ibuprofen, stuff like that. If you're being treated with methotrexate as like cancer chemotherapy, that can lead to folate deficiencies. Okay. Celiac disease, Crohn's disease, alcohol use yet again. Okay. Yeah. And so, and then the PowerPoint ends with vitamin A. So that it's just about everything that I need to know. I didn't get around to the vitamins. The vitamin study guide. I could like close my eyes for like an hour or two and then like wake up and then do the study guide. And then go to school, take my test, and then come home and then like actually get some sleep. Which I think I will do. Okay, so yes. I'm gonna go ahead and I'm going to... I think I'm gonna go ahead and call it a night right here. For now. Just get a little bit of rest. I should get some sleep before my test. So... Yes. I'm gonna go ahead. I think I'm gonna call it right here. No, actually, I'm not gonna end with mitochondria being poisoned by Draco Malfoy. We'll go back over here. We'll go back over here. Okay. And Let me go open YouTube. Oh gosh, I've been streaming for almost 7 hours. No, but you see, I took 2 breaks this time, and I had a snack in the middle too. I had my ice cream. So it's not like I was sitting at my desk the entire 7 hours. But yeah, it was good. It was good. I got a lot studying in today. We went over a lot. I'm gonna go over everything a couple more times for my exam in a couple of hours. 5 hours here. And yeah. Thoughts and prayers. I will try my best to get a passing grade. Yeah, and I think I can do it. It's 70%. I can do it. So, yeah. I won't stall out any longer. I should get some rest. So I'll just go ahead and say that is it for tonight. Thank you to everybody that came by today. Thank you for sticking around for a long time now. Thank you for keeping me company. Thank you for listening to me make my noises. To those of you watching from the future, watching the VOD, thank you also for coming by and sticking around for a very, very long time. Until the end of the stream here. If you were here earlier, you want to come back, watch the rest of the VOD. Thank you also for coming back. So, I will say, hope everybody has a good night tonight. Hope you have a good day tomorrow or today. The sun is up for you already. And I will see you all later. Yes. Good night, goodbye, good night, see you later, good night, goodbye, good night.